paper presentation on fluid mechanics by Indian Society of Theoretical and Applied Mechanics. He has 14 publications in reputed journals and he has 2 PhD scholars under his supervision. I welcome Dr. O.M.P. Sudhar for his talk.
Thank you very much, sir, for a nice introduction. Good afternoon, everyone present. I'll try to keep my talk short because I know that there is already a delay in the schedule. Okay, so I'll try to keep it short. The title of the talk very much is the area in which I am working, that is linear and nonlinear stability analysis of convective flows. In this talk, what I decided to do is that I wanted to give an overview of how hydrodynamical stability problems basically are addressed and what are the different techniques which are there to characterize the stability of a given system. At the same time, I'll mention what are the challenges which are over there, because our conference's theme basically is about what challenges are there, what tools are available with us to study some particular given practical problem. Okay, so before I start about hydrodynamic stability, first of all, stability is a very usual word which is concerned even to human beings. We say that a particular person is stable, and at the same time we say that some individual he's unstable, or even she is unstable, something like that. We say in the case that you do not know the response, or the response is extremely different when you impose certain similar conditions. It is something like you talk to a person, you crack a joke, and the person laughs in one instance, whereas the other instance he just slaps you. So then you will say this person is unstable. Okay, so stability is something like that we try to disturb a given system and try to see that how the system is responding. Okay, so when we talk about hydrodynamic stability, there is one statement which summarizes that what sort of problems we can have is that, and why it is important, is that you have any flow in the nature that must follow the laws of physics, right? That means the laws of fluid dynamics. Fluid dynamics is a very specific part of physics. And then there is one line which is mentioned, it must be stable. So if there is any flow in the nature, it must be stable. It cannot go beyond bounds. Even if you have a river flowing over there, that has a bound. It has to be bounded, otherwise it cannot exist in nature. Okay. So what we will attempt here is we'll check the stability through disturbances, like I just mentioned, that if you want to check stability even of a person, disturb the person. That will tell you that whether it is he is or she is stable or not. So this will be done by disturbances, which we generally call as perturbations. So introduce small perturbations to the system. It will tell you that how it responds to. Okay. And there are some classical hydrodynamic stability problem. These I am mentioning because it is not that the only problem of hydrodynamic stability exists on which I am working. There are even more problems which you can address, particularly young researchers. So there are problems like Kelvin-Helmholtz instability, one of the oldest one. It is about shear effect. So generally stability is about effect, how a system is responding and which effect in the system is most important. So Kelvin-Helmholtz instability is about two fluids which are moving at different velocities in the same direction. But since one of the velocity is slightly larger or one velocity is slightly smaller, then what happens? The fluids start mixing up. And that mixing up happens in terms of vortices. So that is what you see in clouds. On the horizon, if you see, clouds will be having some vortices over there. So that sort of instability is basically known as Kelvin-Helmholtz instability. So here shear effect is important. Whereas another kind of instability which we can talk about is Taylor-Coit flow, in which the instability happens because of rotation. That means the system is there which is rotating with respect to some axis, and due to that rotation there exists an instability in the system. So this you can see even a bottle of water, if you are trying to rotate it, you will see that the liquid is stable. But when you rotate it rigorously, then that will start having some sort of vortices and it will start moving in a different way. So that is what is considered in Taylor-Coit flow. The third one is Rayleigh-Taylor instability, which is about the density effects. So very simple configuration. Again, you have one fluid of some density. That density is higher. Another fluid is there, which is of lower density. So higher density fluid is above lower density fluid. So what will happen? It is obvious that higher density fluid is heavier. Lower density fluid is less heavier. So gravity will work and the higher density fluid will come down. So when it will come down, it will replace the lower density fluid. So lower density fluid will go up. On this mechanism, you see many showpiece items over there where oil and water are mixed. So when you shake that thing, then oil and water will mix, but they will never mix immiscible fluids there. Okay, in such case, whatever stability exists, it happens because of density effects. The last one, which is what I am going to talk about, is Rayleigh-Bénard instability. And this is one of the most commonly occurring phenomena in nature. So this is as simple as this, that in this, what we have is, we have a fluid layer. So just consider, I'll not go by the slides, I'll just mention what it is. So we all actually heat up water, particularly it is winter season. So when you take bath, you want hot water. So if your geyser is working, that is fine. Geyser is not working, then we have to heat up the water in some pot, right? And we heat it on a stove. So that configuration basically is what we have is Rayleigh-Bénard instability. When the boiling point happens, then we say that the fluid which was at rest has started moving. So earlier the heat flow was due to conduction because fluid was not moving. I hope all of you are aware of heat transfer. So heat transfer happens in three ways: conduction, convection, and radiation. So when fluid moves, then we say that heat transfer is happening because of convection. Okay, so before that, it is the state of conduction. So when our water we are heating up, in the beginning, it is having that conduction state. Later on, when you heat it sufficiently for a long period of time, then it starts having what we call as convection. That is called overturning of the fluid. Well, I'll just mention why that overturning happens. Again, the idea is density variations, nothing more than that. So I'll come to the configuration. You can see the configuration is very simple. You have a layer, bottom layer is there. It is heated with the temperature T0. T0 is larger than the temperature at the top, which is T1. That is what we do while heating anything, while boiling water or like milk or anything. And now what happens is when you have the density, when you are heating, it is known that when you have a fluid, and if the temperature increases in the fluid, then the density of the fluid decreases. It is a very common stuff. Almost for all the fluids, it is true. So what we have is that lower near the lower plate, what we will have is a fluid which has less density, whereas at the top we will have a fluid which has, I mean, it is the same fluid, but the density of the fluid there is large. So gravity will come into play, and it will say that, okay, this fluid cannot stay here at the top, it has to come down. But if it will come down, then continuity says that obviously the fluid which is at the bottom cannot remain there. It has to move up. So this happens in a pattern that is what we call as rolls. So here there is a point, there is a fluid particle, it has to come down. So at the same time, some other fluid particle from the bottom layer must go to top. Okay, so this happens in roll. But you can see that we have counter rotating cells. This cell is clockwise, whereas the adjacent cell is anti-clockwise. Why it will happen? Well, like humans, even fluid will take the path of least resistance. So if I have two cells which are rotating in the same direction, that means the other cells particle are going to oppose the particles which are coming down. So that is why fluid particles, if this side fluid particles are coming down, so from this side fluid particles will come down. Okay, that is usual phenomena which even human follows. Let us say if we want to go out of this hall, and if people are moving like this, you are not going to come like this and go from this side. We will also try to go from this side itself. So that is natural phenomena which must happen, and that's why we have always counter rotating cells. So at a time we have to deal with two cells. So that two cell set is called one single cell, which we will talk about. Okay, in entire problem, it is not that we talk about one cell, it is we talk about two counter rotating cells at a time. And now we assume that, okay, this is periodic. So whatever is happening in this one block should happen in all the blocks. That means throughout the layer, it must happen. So like I said, in the beginning, I have just skipped that. The important thing is that these planes which I have considered, they are infinite in length. Well, there is nothing like infinite in length. In nature also, you know, this only means one thing, that I do not want to include side wall effects. Because if I have upper and lower walls, and if I have side walls also, then I have to include the effect of side walls. Because if fluid is going up from the wall, nearby the wall, there is an opposition. There is a friction. So to exclude that effect, we say that we have infinitely extended layer. Well, this way you can say this problem is impractical, but let me tell you it is not. The reason is this, that if I take a layer whose length is sufficiently large compared to its depth, then this sort of thing is common. At least if not near the corners, but at least in the middle, you will have exactly the same scenario which we have considered here theoretically. Okay, and that's why we say that here we should have a shallow layer of fluid. Shallow means a layer whose thickness is less, whose length is very large. Okay, that is what we call infinitely extended layer, excluding the sidewall effects. Okay, so this is the main configuration. What I had planned is like, there are some assumptions which we have to make. So I'll just skip through those assumptions because they are very, very standard assumptions considered for any fluid dynamics problem. For example, fluid is isotropic and so on. These are the examples which I have already mentioned. This problem, why it is important, I'll not go into these now. So here are the things which we consider. Some standard assumption, viscous dissipation is neglected. You can even include it. If you want to complicate the problem, include viscous dissipation. If you want to complicate the problem further, include Joule heating. If you want to complicate further, consider the fluid to be viscoelastic and so on. Okay, so but I have kept the most basic problem of Rayleigh-Bénard instability. So very simple, means most of the assumptions are true for most of the fluids which exist in nature. One more thing, those who are from fluid dynamics, means you can understand that I'll talk only about Newtonian fluid when I said that I am not considering viscoelastic. The modeling of this is very simple. Law of physics have to be applied. So first of the law is that since we are considering an incompressible fluid, this one is equation of continuity. Second equation is equation of momentum. And the third one is energy equation. Okay, very simple, plain and simple, no additional terms, the most basic ones. There is one thing which is which has been added here is called equation of state, and in this case we call it Bose-Nash approximation. So this approximation says very simple stuff. It says that, see, you have density over there, and it is about density variations. Because we mentioned it is about density variations. What is the density at the bottom layer, and what is the density at the top layer? But if you consider density to be a function of temperature everywhere, then it will complicate the problem. So we say, this approximation says this, that it is sufficiently good to consider density to be a function of temperature only in the buoyancy term. That is only in the term where you are talking about the weight of the fluid, because complete phenomena is governed by the weight of the fluid at different portions of the layer. So it says that only and only important place to talk about density variation is the weight of the fluid, that is m times g, or here it is rho times g, because momentum equation is written per unit volume. So m by v, what we become is rho. This is nothing but the weight of the fluid. So only in this term, consider density as a function of temperature. Remaining all places, consider density to be constant. It is rho zero, I have taken here, rho zero here as well. That means density, this is reference density of the fluid. You can say that when we even did not start heating up, what was the density at that time? It is that density. Okay. Mathematical aspects, we need to solve any differential equation, we need some boundary conditions. So boundary condition can be assumed like this, that at lower level temperature is T0, upper it is T1. The boundary conditions are boundaries are either rigid, that means it follows no slip condition, or it may have slip as well at the boundary. Okay, so like I said, I'll not go into these mathematical aspects too much now because I have to cut short my talk. So I'll directly come to how we are going for stability analysis. So this is one portion where we say that we are taking a fluid which is at rest in the beginning. So the conduction state, when I talk about, the velocity of the conduction state is zero. It is the water which is in a pot which is not moving at all. Okay. So when velocity is zero, fortunately, our equations from non-linear, it becomes linear. Because velocity is zero, non-linearity is appearing in the equations only because of velocity. you can see there are two nonlinear terms, v dot del v and v dot del t. So if these two terms are omitted, because I'm saying velocity is 0 in the beginning, so these two terms are gone. So we have simple linear equations to deal with in the basic state. That should be expected. The reason is that your fluid is not moving. So basic state should be a simple one. It cannot be very complicated. Complicacy comes when your fluid is moving with a velocity which is higher. Lower velocity also, Reynolds number is less, everything is fine, laminar flow is there. But when Reynolds numbers is large, then only we have problems over there. Okay, so here I say that conduction state, it is very simple. Anybody can obtain like this. The temperature gradient you will have over there, which is -1. So there is minus Z. If you differentiate this, you will get -1 as the temperature gradient. And you can even obtain other quantities, which will not be required for us. Most important thing required for us is this temperature gradient, which we will use later. Now comes the thing. So there are three basic things I'm going to explain about stability. So there are three mechanisms by which we discuss. The first one is the simplest one, that is called linear stability analysis. So this says that you consider linear equations only. That means when nonlinear terms, whichever you have got, must be neglected. Okay, so this is the simplest one. But this criteria is not always good. The reason is that sometimes it is the nonlinear terms which are important. So I think Sir was mentioning about chaos. I hope you heard that talk of Amitabh Dubey sir. He mentioned that there is an effect, chaos, butterfly effect. Basically, this only leads to butterfly effect. The problem which I am discussing, this leads to that butterfly effect, which says that nonlinear terms are so important that even a flap of butterfly's wing can bring tornado, means flap of a butterfly's wing in Texas can bring a tornado somewhere else. So that other place I don't remember. It should be sufficiently far, because in long run, nonlinear effects are very, very important. For short span, nonlinear effects are not important. That's why weather cannot be forecasted for a very long period. It can be forecasted only for 1 or 2 days. Even that is not absolutely accurate, because there are so many butterflies which are flying around. So you cannot say that which butterflies' wings are going to affect your weather. In other words, in mathematical words, if I say chaos is simply this, that if your initial conditions are even having smallest possible error, then also your results may be drastically different if you solve it for very large time. For small times, that is not a problem. So that is what chaos means. Sensitivity to initial conditions is what we have as chaos. So from next time, if somebody says chaos, just remember this. This is very simple. Means there is no math required for this. Simple thing is this: if your initial conditions are incorrect, your results will be drastically different. Then it should be. That's why weather cannot be forecasted. You cannot measure the fundamentals of weathers correctly at a time. Temperature cannot be measured correctly. Velocity cannot be measured correctly of the wind, and so on. There are hundreds of factors. Humidity cannot be measured absolutely correctly, and so on. Smallest error will cause a big difference in your prediction. Okay, your prediction will be completely wrong. Okay, so we say that linear effect, neglecting linear terms will obviously not be feasible for studying chaos. We must include nonlinear terms. So to include nonlinear terms, we perform two more analysis. One is energy stability analysis and one is finite amplitude analysis. So all the three I'll be covering in my talk. So first thing comes is this. Take your equations, introduce perturbation to the physical quantities. So what are the physical quantities? We have velocity, which is basically 0. So we say that you introduce perturbation means make the velocity non-zero. So that non-zero term I introduce is V dash. Similarly, temperature basically was T basic. Introduce a perturbation, it becomes TB plus T dash. Similarly, pressure is also changed by a small margin. You will see that we are not interested in pressure. We will just delete that term. So when you introduce these perturbations, you get equations, governing equations in what we call as perturbed quantities. Because basic state quantities are known. When you substitute here, there will not be any more unknowns. So what unknowns are basically are perturbed quantities here. Okay, and now you can see that these equations I have got are basically nonlinear. This is V dash dot del V dash. This is nonlinear term. Similarly, V dash dot del T is also nonlinear term. Okay, so we have a system which is non-linear. Now comes the first one that, okay, we do non-dimensionalization. This is very standard procedure in fluid dynamics to make a system independent of size. So whether you perform this, whether you follow my computation in a lab or you follow my computations outside in anywhere, it should not affect. The theoretically what results I am giving, same features you will get in any system which you study. So that's why mathematics is so powerful that we can do on paper and pen what cannot even be done by experimental. When they do experiment, they follow what we have done already. So this is what we should feel proud in being mathematicians, that we are providing theory that yes, at least you can attempt this experimentally. Okay, otherwise they will not go. I have a lot of things to say, but I'll keep it short. Okay, so here we get non-dimensionalization we do, which is, like I said, standard procedure. Again, we have equations which in which we have some non-dimensional parameters. Two parameters I get. Again, remember that these are non-linear equations still. So we have parameters, which is Prandtl number, very standard parameter in fluid dynamics. And second one is RA, which is called Rayleigh number. Now this becomes the crucial factor for us because it is about the temperature difference which boils water or which boils milk and so on. So when you heat from the bottom with high temperature, then convection will happen faster. And when you heat it with very low, that is what we do in our kitchen, right? We keep it slow or we keep it high. So if you keep it high, things will happen faster. If you keep it low, then things will happen slower. So here, this parameter, this non-dimensional parameter which I have is the basic thing which will govern our problem of stability. So it is all about finding the value of RA where convection start. Finding RA basically means where T naught minus, we have to find T naught minus T1. Because remember, remaining all things are properties of either the system which is there. D is the distance between the plates. Alpha is your thermal expansion coefficient. G is gravitational constant. Rho naught is the reference density. And K and mu, kappa and mu, basically thermal diffusivity and viscosity of the fluid. So all these are fixed once you have taken the fluid, once you have decided system. So only thing which governs the stability is T naught minus T1. Yeah. Okay, so here are the boundary conditions. Like I mentioned, you can take either rigid or free boundaries. Okay. So here we go for one thing, that is we can consider the problem, simplify the problem by considering just two-dimensional case. That means in one dimension, we consider symmetry. So this allows us to introduce stream function over there, which is velocities now can be written in terms of stream functions. And the boundary condition continues like this, that the perturbation vanishes identically at the boundary. So all perturbed quantities are zero. Now, there is one more thing we do. Take curl of the equation, which is momentum, and delete the pressure term so that we get an equation which is fourth order differential equation now. Okay, obviously partial differential equation, and the heat equation becomes second order, which is right from the beginning, it was second order. Now we come to the governing equation which we have. So these are the governing equation. J here represents Jacobian. So Jacobian of psi and del square psi, and this is Jacobian of psi and t. These are the nonlinear terms. Now we come first linear stability analysis. Very simple idea. Neglect nonlinear terms. So when you neglect nonlinear terms, then you get these simple equations. So these are linear equations. And now we assume what we call as normal mode analysis, in which we say that all the particles which are available, they are going to move in the same plane. In that case, I can assume psi to be in terms of sine AX, and t I can assume in terms of cos AX. With that, we have time dependence also we are removing here, and we are saying that time dependence will be e raised to the power lambda t. So this is the idea of stability, that if lambda is positive, the system is not stable because it will grow with time. If t is negative, lambda is negative, then as time increases, system will be stable. So there is a point where marginal stability happens. That means when lambda is equals to 0, that is the point which we want to find, because below that, we are always going to have stability, and above this, we will always have instability. Okay. So lambda equals to 0, we are going to put for linear analysis. So when you put it here, and these linear equation, when you solve it becomes very simple. Ultimately, you get a matrix form in which lambda times AB is equals to this matrix times AB. And now we say, like we said, lambda equals to 0 is the point we want to find. So we have a system A times X equals to 0. Obviously, we are not interested in zero solution. So we say that we want to get non-trivial solution. For this Rayleigh number, you can obtain like this. That is determinant of the matrix. If you make 0, then we get the Rayleigh number. This Rayleigh number is obtained as 657. Okay, for the case of free boundaries. For the case of rigid boundaries, it is 1700. For the case of rigid free boundaries, it is 1100 about. Okay, similar analysis we can do for rigid boundary. The second comes, this is the most crucial, and I'll say one of the most important analysis, that is called energy stability analysis. Here it says that check the stability of the system at t equals to 0. If that is finite, check the stability, check the energy of the system at other time. If that is also finite, then we say that system is stable. Okay, so that is called energy stability analysis. So if there exists a gamma such that initial energy is less than this, and limit t goes to infinity, et goes to 0, then we say that the system is stable. Now, the idea here is this, that this analysis gives the superior bound than linear stability bound. So this will tell us really the stability bounds, that below this system is always stable. Linear analysis gives us bound beyond which system cannot be stable. That means it will be unstable. Okay, so these two analyses are completely different. So idea is same. Take the equations, define an energy. This energy is L2 energy. You can see that we have defined in terms of norm, function norms. And now find this relation d by dt is equals to, some terms are there which is obtained like this from the given equations. Here you can see there are non-linear terms which are included. So we get 3 types of terms. One is P term. It is about energy production of the system. So this is the term which says that energy is produced in the system. D term actually is with a negative sign. It is about dissipation of the energy, that this much energy is consumed from the system. And N is the term which says these are non-linear terms. So the idea of energy stability analysis is just this. Prove that these non-linear terms are not significant. That means prove them to be less than D or P. If you can do this, then this term can be neglected. So once we do neglect this, we get the relation that d by dt is going to be negative. You can see I have taken d outside. So what is left after you neglect n is basically p minus d. So out of this, take d outside. So when you take d outside, you get d by dt to be minus d into 1 minus m. So we say that d by dt will be negative if m is maximum 1. If m is maximum 1. From 0 to 1, it will be negative. So we say that what we have to apply for stability is m should be maximum of p by d. Here comes the thing. Remember, p and d are basically some integrals, inner products. So here comes calculus of variation into picture, because we have to minimize something. So once you minimize, you get Rayleigh number by this. So here is the thing we have to do. We have to find Rayleigh number which is minimum with respect to a and maximum with respect to lambda 1. So when you find this, well, depending on the problem, this is one of the recent results we published, I think in Journal of Magnetism and Magnetic Materials. So in which we got stability bounds by linear. These are the stability bounds, which are much larger than the energy stability bound, which we are calling as non-linear bounds, because energy stability includes the non-linear terms also. So you can see that what it is saying is that below green line, your system is always, below blue line, your system is always going to be stable. Above red line, the system is always unstable. In between, there is a shaded region. It says that here there is a possibility of what we call a subcritical motion. That system may have some motions which are not exactly rolls, but there may be some motion. That means fluid is not at rest. It might be moving. Okay. So last stability analysis I'll quickly go through is this finite amplitude, which says that now you give the disturbance but not neglect nonlinear terms, retain the nonlinear terms, and calculate these terms also. So while we want to include this, this is the work of Professor Edward Lorenz from MIT. He proved that chaos exists in real world and weather cannot be predicted. The thing which I mentioned to you, he said that you have to take these two expansion. The reason is that when you calculate this Jacobian, it comes out to be sine 2 pi z. So we say that in temperature, you cannot just have sine pi z, which we have done in linear analysis. You have to include an additional term, which is sine 2 pi z. If you want to go further, then you must include sine 3 pi z, sine 4 pi z, and so on. Okay, so he said that include this, and then you will see chaos. Before him, nobody saw this. And it happened in 1970s. Okay, so that time he was using some computer by which he realized that chaos is there just by rounding off errors. So when we substitute here again, finite amplitude analysis says this, you write the equations which we had. The only thing you have to do is to marginal stability. That means lambda should be 0. So all left hand side becomes 0 and we can find out the values of A and B over there. So here is one again result which this is last. So this is one of the article which we published in I think 20, in which we found one problem in which all the 3 stability analysis produces different results. So this is something rare which happens. That first line, the uppermost line is the linear analysis, which says again that above this system cannot be stable. That means instability is there. This dotted line which is at the bottom, which is energy analysis, below this the system is always stable. And finite amplitude analysis is exactly between those two. It says that yes, there is convection even below the linear limit and above the energy limit. So remember, linear and energy, everything has to be between that. So if convection is happening, it has to happen above the energy limit and below the linear limit in all cases. Okay. So with this, there are some challenges which are possible since the theme of the conference was there. The problem with the hydrodynamic stability is you should know the basic state, because basically basic state stability we are checking. So knowing the basic state is one of the biggest challenge, because basic state includes non-linear terms. We avoid it because we took velocity to be 0. We could avoid it, but in all problems you cannot avoid it. So solving nonlinear differential equation is the biggest task, and that is why theory of hydrodynamic stability is limited to a number of problems only till now. So this is one open area in which you can work when you include basic state to be having nonlinear terms over there. Okay. And there are more things, like I assumed a symmetry. I mentioned to you, converting the problem into 2 dimension. I assumed symmetry in 1 direction. So that symmetry, if you avoid, then also hydrodynamic stability things are difficult. Okay. And well, we are addressing this third one nowadays. So I included that addressing problems in which external forces are basically time dependent. Okay. With this, there are some references. Very nice books are there by Professor S. Chandrasekhar. I hope you have heard about him, Nobel laureate. He worked in this field. Professor Subramaniam Chandrasekhar. That is the first book. And those who want to read about hydrodynamic stability, first 2 books are the best, Drazin and Reed and Subramaniam Chandrasekhar's book. And these are some references which I have used. If there are any questions, you can ask.
Any questions? Any questions from you, sir?
Okay, thank you very much. Thank you.
We have many students of fluid dynamics here. The time limit is very much we can stand. Thank you very much, sir, for your thought-provoking lecture on fluid dynamics. I personally, a student of fluid dynamics, I like this lecture, so I forgot to make you in the limits of time, in spite of many reminders. Thank you very much.
I request Professor Pankaj Mathur sir to present memento and certificate to OP sir. Thank you so much, sir. Now I invite Dr. Amna Khanum to introduce the next speaker.
A very good afternoon to all of you. I am Dr. Ulka. I welcome you all in this afternoon session. And in this session, the talk is going to be delivered by Professor Shivi Agarwal, and the session will be shared by Professor Salla Parikh ma'am. So I request both Professor Agarwal and Professor Parikh to take their respective positions.
Very good afternoon to all of you. And it is really happy moment for me to introduce Professor Shivi for this talk. And when we talk about Professor Shivi, she did her PhD from IIT Roorkee in 2008. And at present, she is Associate Professor in BITS Pilani in Mathematics. She has published more than 40 research papers in reputed journal. And 2 students has done their PhD in her supervision. And the ongoing number of ongoing students are 6. And actually, at this time, the Dr. Shivi is giving her expertise in so many fields. And those fields are efficiency and productivity, data envelopment analysis, data envelopment analysis in transport sector, data envelopment in health sector, Malchus productivity index, fuzzy data envelopment analysis, fuzzy set theory, neural network, multi-criteria decision making, and last but not least, fractional calculus and its applications. Now, welcome, Professor Shivi, for your talk.
Thank you. That's nice introduction to me. So very good afternoon to all of you. Myself Shivi Agrawal from BITS Pilani. So the title of the talk is application of integrated data envelopment analysis model with fuzzy set theory. Actually, in this one, we are integrating the 3 things. The first is data envelopment analysis, that is the optimization technique. And when we are just apply in a real life domain, as the conference says, the real life domain, real world domain. So we are using the data and there is some inadequacy in the data. So we have to use the fuzzy set theory. So we integrated the DEA models with the fuzzy set theory. And then we are just doing the real life domain application of the fuzzy DEA basically. So that is the concept which we are using here. Now, when we are talking about if we are talking, we are sitting some persons somewhere in a meeting, so they're always talking about the ranking, or if we are academicians, so we are talking about who is the best institute. If you are going to take the admission, so you are also taking care of the which is the good institute, so that our student or our children will get the admission, which branch we have to select. Everywhere we have the ranking system in that one. Okay, which institute is performing well, which hotel is the good performer, so that we can take the room in that one, which hospital is doing well, so that we can take the their services from us. So that is the ranking system basically, and it is a very real life domain challenge which we can consider that how we can just rank them. So in academic higher institutes, we can say that these are the main ranking systems which we are talking about, the national level, NIRF, and for the globally we can say the QS ranking system. Similarly, we can say the top hospitals in India, and the trip advisor also give you the ranking of the hotels if you are just going to trip somewhere. So that is the actually challenge, that how we can rank the DMUs, that is the decision making units, for example hospitals, institutes, and hotels, etc., everywhere. So that is the important aspect, that why ranking is important here, because here our challenges are what, that it is a competitive world. So many hotels are there, so many hospitals are there, so many institutes are there, so in which we have to just take care, which we have to consider for our problem, so that we have to do the ranking. So for that we can consider here the changing nature of work, increasing competition in real domain, so many improvement initiatives. We are just going for national and international awards as well, and changes the organization role and the power of information technology. So as to that, we can say that is a regular assessment of the performance for each individual is very important, and then so that they can compete for ranking system as well. So firstly, we have to check our assessment, our performance, and then we can go for the compete in the real world domain. That is the concept which we are using here. So here we are just taking a data envelopment analysis, a technique, which is the ranking, and this is also known as the multi-criterion decision making. So we are taking the multi-criteria, how we can consider it. Here I am just taking a one example for 4 engineering colleges, because here we are academicians, all are academicians. So they know about the institutes, about the engineering college. So if we are taking the 4 engineering colleges, and these are the 1 input and 1 output, if we are taking the 2 criteria only, so directly we can say, okay, we are finding the productivity and by output upon input, and we can say, okay, this first one is the more efficient and other are not efficient. So we can rank them easily. So that is very easy task. But if we are taking the more inputs and outputs, means multi-criteria if we are taking. So here you can see in this one, when we are taking the output upon the first input, that it is highest, but in this one, the C is the highest. So which is the highest one? Which is the efficient one, or which we have to consider? So for that type of problem, the frontier analysis comes into the picture. And in this one frontier analysis, we are making the frontier, and we are saying that the DMU, which is on the frontier, that will consider as efficient, and we will consider for our assessment here. Similarly, we can go for the multi-criterion. So here we are taking the example of 2 input and 1 output, but we can go for the multiple inputs and multiple outputs as well, because we know in the real life world, we don't have only 2 inputs and 1 output, or 2 outputs and 1 input. So we have to move further for that. So that's a frontier analysis comes into the picture, and that is introduced by Farrell in 1957. After that, not so much work is done, but in 1978, Chance, Coopers and Rhodes gave the linear programming problem for frontier analysis, which is known as the data envelopment analysis. So they are making the frontier, which is known as the envelopment, and they are just make the envelope on data and do the analysis and then rank the DMUs. DMUs means decision-making units here. So after that, they are using the constant returns to scale. That is the economical word, basically, based on the size of the institutes. Then they are just using, in 1984, Banker, Chance and Cooper add the convexity constraint to make the variable returns to scale, means the size of the institutes also matters, because we can't just compare University of Rajasthan with a smaller deemed university or smaller institutes. So we have to take the care of the size of the institute as well. So that we can use by the next model. So what is the DA and how we can compare with the multiple input and output? So here we can consider M inputs as outputs, and we are giving the weights, and based on that weight, we are finding a linear programming problem. Due to the time constraints, I am not explaining about the model here, because this is models Chance, Cooper and Rhodes gave the model in 1978. This is a linear programming problem, basically, and due to the time constraint, I am not explaining about the DA, about this model as well. So now why we are using the data envelopment analysis over the other techniques as well? Because there are so many merits here. In real life world, we have the inputs and outputs. They have attached to each other, related to each other, but we don't know the functional form. So we are not saying that they are linear in nature. We don't know the non-linear in nature. If they have the non-linear relationship, so what is that? So we don't know. So at the time we can use the data envelopment analysis. Similarly, we have the linear programming problem based. So that is very easy to solve with. And here we can use the multiple inputs and the multiple outputs criteria. So many, we can say that so many benefits of the DEA over the other technique. So that's why we are using this technique easily. And we can also find out the scope of improvement by using the data envelopment analysis. So that is a very good technique, which is a linear programming based technique to find out the ranking of the DMUs. Now, next is why we are using fuzzy set theory. Why we integrated the fuzzy set theory? Because when we are taking the data for the real world, that data may be inadequate, or you can say the imprecise in nature. Same, we can say the some missing data as well. We have the secondary data which is not given properly. We can also have the qualitative type of data. So at the time, how we deal this data? So we are dealing the data by the fuzzy set theory specifically. So we integrated the fuzzy set theory in the LPP, and we are making the fuzzy DA model. And in the fuzzy DA model, we are making the fuzzy linear programming problem. And for the fuzzy linear programming problem, there are many ways to solve it. So we are using here possibility level to solve it, which makes the multi-objective linear programming problem, which is again very difficult to solve. So again, we are applying some methods. Due to the time constraint, again, we are not explaining so much about these. But if you have any doubt, and if you want to pursue that things, so you can contact with me specifically. So in the case, we are making this is the fuzzy linear programming problem, and we are solving it by the multi-objective linear programming problem. You can see here there are two objectives, and we are saying so many constraints. So we are just converting into the single linear programming, single objective function with a different parametric word h here, and then we can solve it. So it will become a crisp linear programming problem, which you can solve by the MATLAB, Mathematica, any software you can use to solve it. And you can apply the real world data on it, and you can find out the ranking of the any institutes. So this is the second part, and third part is the application. So here application, there are three application which I want to discuss, but due to the time constraint again, because we are having so much perturbation, and the organizers are not feeling stable in that one. So that's why I don't want to make more perturbation in that case, and we want to optimize the time. So that's why I'm just telling you the application, simple application, that is the green supplier. Because nowadays you can see that everywhere we are using the outsourcing. If you're just applying here the conference, in this one again, this all systems are outsourcing. This is not from the institute side. Okay, so and at time they have the so many options. So which they are selecting, which option they are saying that this is the, and in this one now so many environment regulations. So at the time we are selecting, okay, green environment suppliers, okay, which just having the our environmental regulation which can follow it. So that's we are just using here. So you can see here we are just using the green suppliers, where the two type of inputs we are taking and three types of output we are taking here, and they are fuzzy in nature because we are using the environment impact. That is not nature, you can say fuzzy in nature. So you can see we are taking a data of 10 suppliers, cost, it's the simple input, but environment impact, we are using the three things. So at a time, this is a expert opinion. They are saying, okay, they are doing good in that one, they are doing bad in that one, they are average in that one. So at a time, that is a qualitative data we have. So we can apply the fuzzy set theory in this one. So here, the outputs we are considering here, and in the output, the quality. Again, quality is also a qualitative type of data. So at it is, again, we require the expert opinion for that, and we can convert the data into the fuzzy numbers, and then we apply the fuzzy DA for that. So we have done this work, and in this one, we are converting the data into the fuzzy numbers, and based on the fuzzy numbers, you can see here, these are the fuzzy numbers, and we just taking, okay, this is the data for the supplier A, and then we have the data that these are the fuzzy numbers, and then we apply the inputs and outputs, we put in the linear programming problem, and we find out the results. And you can say this is the different results for based on the value of H. And from that, we can rank that G is the most efficient one. So the first ranking is for G, then we can go for the E, and so on. So we can rank them, and then accordingly we can contact them for our supply. Okay. Similarly, we can say that in this one, we can also use the model where data is not controlled by the suppliers. For example, distance function, if we are taking. So distance is not controlled by the suppliers. They can't change the distance from institute to their destinations. So at a time, that also be considered in the data and we can find out the results as well. So this is the first one. So second one for the state road transport sectors. So as I told you, in a fuzzy set theory, we are applying mainly in the three things, that is the qualitative in nature data, missing data. So here we are applying the missing data. So here we are using the data from CIRT, that is the secondary data for the 24 state road transport undertakings. And you can say here, these are the missing data. So we convert these missing data into the fuzzy numbers, and then we can apply the fuzzy set theory in a DEA and we can find out the efficiency, and then we can rank them accordingly, and then we can find out also the scope of the improvement. So we can just do that work and we can find out this is the result that, okay, VPM, that is from Tamil Nadu, having the first rank, and the PMT, that is the Pune municipality transport sector, having the worst performance, in the last, having the rank 24. So that we are ranking them, and we can say there is a scope of improvement. They have some where they will just change their allocations, resource allocations, so that they can be improved and they will become more efficient. So this is the conclusion, that we can convert the missing data or qualitative data in the fuzzy, and then we can apply the fuzzy DA, and there is a uncertainty always in the mind. Okay, we are not certain in a mind, in our mind, human mind is not certain. Always we are changing our thinking. So it is uncertainty, and that uncertainty we can include in our mathematical model and to find out the solution as well. These are the some references. Any question? Ma'am, I tried to optimize the time. Yes.
General question I have, because you show number of inputs allowed. My general question is, do we optimize and do we come before we get a compromise solution?
Actually, it is a compromise solution. It is completely based on the what criteria you are selecting. So at a time, we are just saying what operational efficiency we are taking, which is based on these criteria.
We can say it's not optimization, it's a compromise.
Exactly.
Based on
Criteria, completely based on the criteria. Because if seeing the for institutes, so a person who want to take the admission in that one, they're saying, okay, which branch is good? Branch is good means what? Teacher is good, placement is good. What thing? According to your priority, you just rank them. So according to the criteria, you set your priorities and accordingly you rank them and you are taking the admission. So this is again a real life problem. Thank you. Thank you so much.
Thank you, Dr. Shivi, for such an informative and good lecture. Thank you very much.
Thank you all.
I request Professor Challa ma'am to present a certificate and token of memory to Shivi Agarwal ma'am for
Yes.
Sir, he is having so many portfolios actually. All the things they are right on. Thank you.
Thank you, Salah ma'am and Shri ma'am. Now I request Salah ma'am for the talk, and I request CV Gupta sir for chairing the session.
Good afternoon, friends. In fact, I feel honored to introduce Sarla Parik Kalves because I'm a little bit small worker the field she represents. Sarla Parik presently working as a Dean Faculty of Maths and Computing at Banastali, University of Banastali. Earlier to this, she was heading the department. She has published more than 100 papers in reputed journals and produced about 30 PhD scholars and 12 MPhil scholars under his guidance. One more thing, in fact, we have very less people who have left the administrative job and joined this noble academic. In 1992, she was selected Indian Statistical Services, scoring 3rd position. But she decided to join academics and did not join this Indian Statistical Services. The topic, in fact, I was just, it is a little bit of my interest because I do very little research in this topic. That is the title of the talk, which she is going to talk. Development of stochastic inventory model with 2 storage capacity for deteriorating items under credit financing policy. So I welcome you, ma'am, and request you to talk, but in limited time. So sweet and limited talk.
Try my best.
All the best. Thank you. Please.
Yes. Actually, the topic is about inventory modeling, and the conditions are, the demand is stochastic. This is the main, but other conditions are also taken into consideration. That is when there are 2 storages are there. Why only the 2 storages? This will be take up in the next slides. So first, what is the inventory? We know all that in our house also when we cook rice every day, but we do not go to purchase rice every day. We keep the store of rice in our houses for fulfilling the future demand. Sometime. So what is the actually inventory that is defined? That is the stock which will kept for future, fulfilling the future demand. And so as the in houses, rice or wheat or wheat flour are kept in stores. Similarly, the sellers also may keep the inventories of the selling of items. And the one thing then there are so many items which we have to keep in the stores. So how the we keep the or we have to manage the inventories, or how to optimize the things in inventory. That is the area of inventory management. So inventory management is the what item should be the stock, and when another thing, when the order should be given, when we have to purchase the rice for next month. That is the one question. Another is how much, 5 kg rice or 10 kg or just 2 kg. So that is how much, or what items, rice, sugar, or those items that we have to also have answer for that. So this is the inventory management. Next, when we get the what are the types of inventory, we can see the raw material and all these things. You can, I think, understand the components are sometimes which are used for the inventory. Some finished goods are there, and some may be used in the maintenance. All these may be kept into the store or in our stock. So these are the types of the inventories. And now when we come to the manage the inventory, or then the mathematicians always go for the constructing the model for that. And when they try to model the situation, then they keep that how they make the model or how they construct a model. So what are the parameters or what are the things to be considered? So these days what we can see that everywhere in corporate hospital or there, even for the doctors, they see the doctor how much profit giving to the hospital. That is known as the good doctor in respect of the hospital, not in respect of the patients. So in respect of the hospital, they think that the doctor who is making more profit is a good doctor for them. But naturally, they then see that for whom which doctor the patients are going, those are the customers. But everything these days is measuring or optimizing in terms of the cost, what cost. So in making the inventory or keeping the inventory, what costs are involved, then we try inventory modeling, those costs are optimized or minimized. So on that condition, the models are built. So when we think talk about the task of inventory management, then one thing, customer satisfaction we see. If I go for the my car repair shop, then again the same day I will call, please give the feedback. So everyone knows the customer's feedback. So customer satisfaction, and definitely we want to keep the cost very low. And another, maintain the inventories, ki kaise kin which items are. So these are the important tasks. And when we come to the modeling of the inventory, then first in Harris in 1930, in one paper magazine of management, I think that name was The Factory. And in that magazine, in 1930, Harris published a paper regarding this EOQ model. That was the first, but that was not so much known. After so long, many years, it was recognized. But first was the Harris who make the or put the inventory in the mathematical modeling. That was the very simple modeling in which the two costs were kept in mind. One is ordering cost and another is ordering cost and another is carrying cost or holding cost. So these two costs, both costs have to be minimized, but simultaneously those cannot be minimized simultaneously. So what is being done? The total of the cost is being minimized. And for that, it was seen that At this point, where it is minimized, that is the both the costs are same. So this is the model, and this we can see, this is the how the inventory, only the linear deterministic, the constant demand rate is there, deterministic demand is there, and the when order is placed, when order is reached, that time gap is known as lead time, and as soon as the order is placed, the inventory is replenished. So these are the elementary conditions or elementary inventory model, which when the modeling was done. And after this, the production is also taken into consideration. Then EPQ model came into existence. And here you can see that simultaneously production starts, and in demand is also there. So this is production rate minus usage rate. This is when production is stopped, only inventory starts to deplete. So this is known as EPQ modeling. But now the questions, when if we want to add more and more conditions, then how we think that is only the demand by which the inventory will diminish? No. Then other thing, some items may be, says when I take the example of rice, we can see some deterioration after some time on the rice. So due to the deterioration also, the items can diminish. And are they in inventory, or jo hum seller and buyer, we are taking the two players, are only the two players in the inventory management? That is also no. Then there may be many players in inventory management. Then the supply chain management concept comes into the picture. So when we talk about the deterioration, I think everyone understands what is the deterioration. So we can skip this. And what are the governing equations when we consider the deterioration? This is the picture. Till time TD, there is no deterioration. When we keep the stock or we purchase the rice, for some time there is no deterioration. After some time, deterioration starts, and here we are assuming that demand rate is constant. So up to this interval, the governing equation will be this. But when the deterioration starts, and here we are considering the deterioration is also constant, so this will be the governing equation. Now, this is the picture of supply chain management. The manufacturing, distributor, retailers, and after that customers, and manufacturer के लिए भी क्या होंगे? Suppliers होंगे. कौन से suppliers? Who will provide the raw material to the manufacturer. So this is the picture of the supply chain management. So these days, when we talk about the cost in totality, the profit of all, the overall profit is to be maximized, or overall cost is to be minimized. These are the objectives of supply chain management. When we consider that coordinated teamwork, then reduce the operating expense, enhance customer satisfaction. हम hand to hand, hand in hand काम करेंगे, तो naturally मिलजुल कर काम करेंगे, तो उससे फायदा ही होगा. तो this is the concept of the supply chain management. Now we are in the position of saying what are the factors affecting the inventory system. Deterioration, lead time, time horizon, inflation may be also there. Now, what is the demand? Demand naturally plays very important role. So these are demand may be deterministic, may be probabilistic. Why probabilistic? That we will consider in next slide. And demand may depend, independent, will not depend anything, and may be dependent also. Now, in the few back slides, we considered the constant rate demand, deterministic demand, but is demand always deterministic? No. Why? Because in reality, demand shows random behavior. So when anything becomes random, concept of probabilistic or stochastics comes automatically. Now, we also know that everyone wants to increase the profit, and how profit will increase? When demand will increase. For sellers, the demand will increase. So how demand can be increased? Advertisement, through trade credit policy, and many other policies. You know, buy one, get one free. Buy three, get all for one free. Or buy this time, pay later, or so many. If you will buy in a lot, you will 5% or discount or 10% discount. All are the trade credit policies which are being used this time. And online shopping we can also see, na? Or time to time ki wo deal of the day are there. So that is what? That is also a trade credit policy. And the cashback and all these things. Or displaying stocks. When you go to the any mart or any shop these days, you will saw that something is displayed. तो हमें नहीं भी खरीदो, ध्यान आता है, हाँ खरीद लेते हैं. क्यों नहीं खरीद लेते हैं? अभी काम आएगा, डिस्प्ले हो रहा है, अरे ये आइटम तो अभी देखा, नहीं तो मैं तो कितने दिन से ऐड में देख रहे थे और तब तो हमें मिला ही नहीं, आज तो स्टॉक में दिख रहा है, चलो खरीद ही लेते हैं. So that all these things affect the demand. Other factors also, these are the other factors which affect the demand. Now, how the trade credit, which we have discussed just now. So how the equations or modeling include in the demand, that is, this is the period M. Up to M, I suppose I purchase, I am the retailer, I purchase from the wholesaler, and wholesaler says that if up to this period you will give the money, then you will not charge any interest. So what will I do? मैं अपनी दुकान पे ले आई and I start to sell. तो डिमांड आ रही है, मुझे तो पैसा मिल रहा है ना, तो मुझे पैसा मिल रहा है, तो उस पैसे पे मैं तो क्या कर सकती हूँ? I can earn the money. ये वैसा नहीं है जैसा हर्षद मेहता ने किया कि उसने उस समय का लिया और उससे इंटरेस्ट कमाया, और ये नहीं, ये बिल्कुल वाइट वो चीज है कि एम तक उसने हमें दिया था पीरियड, अलाउ पीरियड, तो एट दैट टाइम हमने क्या किया, उसमें जो भी डिमांड उस समय तक गई है, उस डिमांड के लिए प्रोडक्ट हमने बेचे, वो पैसा मेरे पास आ गया, ऑन दैट मनी आई कैन अर्न द मनी. लेकिन इसके बाद में, इस टाइम के बाद यदि मैं पे करती हूं तो मुझे क्या होगा कि फिर देना पड़ेगा. ठीक है, तो ये यदि एम यहां तक ही है, तब तो क्या होगा, मुझे इंटरेस्ट चार्ज भी होगा, इंटरेस्ट अर्न भी होगा इस समय तक, और इसके बाद इस पीरियड तक इंटरेस्ट चार्ज भी होगा मुझसे, क्योंकि फिर तो जो सेलर है, वो जो होलसेलर है, वो उससे चार्ज करेगा. एंड इफ एम इज देयर, इफ एम जो पीरियड है मुझे यहां तक दे दिया कि मेरा साइकिल है, जब तक मेरी इन्वेंट्री में अभी 100 का लॉट लाई थी, जब तक पूरा नहीं बिक जाता तब तक मुझे टाइम अलाउ कर दिया, तो मुझे इंटरेस्ट क्या होगा, ओनली अर्न, नो लॉस. So all these things are also. Now, there comes, हमने trade credit policies, through trade credit policy or stock display, what we have done? We have produced huge demand. And huge demand means, इतना पीछे तो नहीं जाना था. Huge demand, huge inventory. Huge inventory means need huge space. Huge space, रेंटेड वेयर हाउस. अभी बॉम्बे जैसी जगह में तो क्या है, आपके पास 2 BHK 1 BHK मुश्किल से ले पाते हैं. ठीक है, सामान तो हम इंडियंस हैं, वी आर इंडियंस, सो हमारी हैबिट हो गई बहुत ज्यादा स्टोर करने, पता नहीं कब काम आ जाएगा. तो क्या करते हैं, लोगों ने इसका फायदा उठाना चालू कर दिया, एंड रेंटेड वेयर हाउस की तरह वो भी रेंट में देने लगे कि हम अपना सामान वहां जाकर कम कीमत में रख सकते हैं. और जब हमें जरूरत हो तो हम ला सकते हैं. तो दिस इज द कि रेंटेड वेयर हाउस. तो हम देखते हैं ना कई बार ये कोल्ड स्टोरेज है, यस ऑल दीज आर. तो सबके पास, शॉपकीपर्स के पास, ऑल द शॉपकीपर्स डू नॉट हैव द cold storages to say purchase the space. That is the concept of rented warehouse. So this is the warehouse strategy. So warehouse strategy mein the inventory managers must know how many warehouse should be employed to keep the inventory. Second question concerned which warehouse type, cold storage or just space or just nearby to me or just far away from me. जाते हैं हम कई बार ना, अभी कपड़ा ये वाला हम मांगेंगे, ये वी नीड दिस टाइप ऑफ क्लॉथ. शॉपकीपर से वेट आई एम गोइंग टू द गो डाउन एंड आई विल ब्रिंग. सो दैट इज द रेंटेड वेयर हाउस. बट इन्वेंट्री मैनेजमेंट में जो नंबर ऑफ हाउसेज है, दे आर केप्ट इनटू इन 2 कैटेगरीज. नंबर में कई हो सकते हैं, but they are only 2. One is own warehouse, another is rented warehouse. Rented house में 4 or 5 हो, they are considered as 1. Own warehouse मेरे पास 4 warehouse है own, लेकिन all will considered as 1. Now what we are considering here, the stochastic demand we are considering, which is variable. और वेबल डिमांड इज, आप ये कह सकते हो कि हाईली कोई एक्सपोनेंशियल, डबल ट्रिपल एक्सपोनेंशियल नेगेटिव हो, दैट इज वेबल डिस्ट्रीब्यूशन डिमांड. और वी कैन नो, वी कैन थिंक दैट ऑल द सम फैशन गुड्स और सम इस तरह की जो गुड्स हैं, दे विल नेगेटिवली एक्सपोनेंशियल, और उनका जो ऊपर का ए जो होता है जिसको हम कहते हैं, वो बहुत ज्यादा हाई हो सकता है कि बहुत तेजी से डिक्रीज हो रही हो. तो इस तरह की होती है. तो इन दिस वी कीप दैट, इसमें ही हमने माना है कि शॉर्टेज नहीं है, रिलीड टाइम 0 है. और एक उसकी मेरा जो ओन वेयर हाउस है उसकी लिमिटेड कैपेसिटी है, दैट इज W. सो दीज आर द सम assumptions and these are the notations which are used in this model. And this is the modeling, that there are 2 warehouses, own warehouse and rented warehouse, and the result. So this own warehouse, the capacity is W, and if this is up to Q, then this Q minus W part is kept in the rented warehouse, and it is known that up to time TW there is no deterioration, and up to time T1, आप देखेंगे T1 तक हम रेंटेड वेयर हाउस में से ही चीजें ले रहे हैं. सो T1 वी आर, द डिमांड इज फुलफिल्ड थ्रू रेंटेड वेयर हाउस, and up to TW there is no deterioration. So in own warehouse, the inventory diminishes due to only the deterioration, and in own warehouse, so rented warehouse is TW time only due to demand, and after that demand and deterioration both, and up to this TW to T1 in rented warehouse only due to the deterioration, because after this time T1 we start fulfilling demand from our own warehouse. So then that is actually जो ग्राफ है ये थोड़ा और, क्योंकि we are here considering the variable demand, so this should be the curve इसमें और नीचे होना चाहिए था, but मुझसे अभी ड्रॉ नहीं हुआ, so I will, इसको मैं ठीक करूंगी कि इसका जो ये नीचे का है ये और कर्व होना चाहिए. एंड दिस इज एट द ओन वेयर हाउस, फ्रॉम ओन वेयर हाउस, एंड ओन वेयर हाउस आपका डिमांड से भी कम हो रहा है और डिटरेशन से भी कम हो रहा है. एंड दीज आर द गवर्निंग इक्वेशंस फॉर, these are the for rented warehouse, these are for the then so these are the governing equations. and these are the solutions of equations. Then the costs are calculated for these जो हमने डिफरेंशियल इक्वेशन को सॉल्व करके जो क्यू निकाला है उससे करके ये आपकी ये कॉस्ट आ गई है. टाइम पीरियड अलग अलग है, सो इंटीग्रेशन से फिर कॉस्ट आ गई है सारी. एंड ऑन वेयर हाउस के लिए हो गई ये सारी कॉस्ट. इन दिस दीज आर द 3 केसेस, 3 केसेस लिए गए हैं. इनको भी यू कैन सी इन द ग्राफ एंड अंडरस्टैंड हाउ द case interest is earned and how interest is charged that were considered. So cost, that cost also. So when we come to, these are the cases of trade credit policies, and our aim is to minimize the cost. So we minimize the cost by maxima minima rule, and we have seen that these are greater than 0. So naturally we are minimizing the cost, and through the numerical analysis we did the sensitivity analysis, and with this sensitivity analysis how the one parameter affect the cost and other factors. So this graph, from this graph sensitivity analysis, we can see which parameters are significant. So if we can see that here the cycle time, as cycle time increases, the total cost decreases. But you can see after some time, this आप साइकिल टाइम कितना भी इंक्रीज कीजिए, आपका जो टोटल जो कॉस्ट है वो क्या हो जाएगी, आपकी कांस्टेंट होने लग जाएगी. एंड दिस इज द स्केल पैरामीटर का जो इफेक्ट है, वी कैन सी दैट इज द, इफ वी सी द ग्राफ देन यू कैन सी दैट दिस इज द लीस्ट सिग्निफिकेंट पैरामीटर. ये ज्यादा इफेक्ट नहीं कर रहा और एक टाइम के बाद तो ये सबके लिए सेम हो जाता है. तो इसके बाद आप बीटा की वैल्यू कितनी भी इंक्रीज करें, दैट विल नॉट अफेक्ट द साइकिल टाइम, क्योंकि साइकिल टाइम आपका बीटा से अफेक्ट होगा और वो उसको अफेक्ट नहीं करेगा. टोटल कॉस्ट, व्हेन वी सी द इफेक्ट ऑफ बीटा ऑन टोटल कॉस्ट, देन ऑल्सो वी कैन सी दैट एक्चुअली दीज आर द कैपेसिटी ऑफ ऑन वेयर हाउस. तो ऑन वेयर हाउस में आप कैपेसिटी से आप देखेंगे कि यदि आपके उसकी कैपेसिटी कम होगी तो आपकी जो टोटल कॉस्ट है वो शुरू में क्या हो रही होगी, रेंटेड, इन दोनों से क्या होगी आपकी, देखिए कम दिख रही है. लेकिन एक समय ऐसा आता है कि आपके खुद के वेयर हाउस में आपकी कैपेसिटी लिमिटेड है, कम है, तो बीटा की बाद की वैल्यूज के लिए वो क्या हो जाती है, बहुत इंक्रीज हो जाती है. And so these are the conclusions. The capacity of W increases the optimal cycle time. The ordering cost, time T, are correlated. Cycle time, demand are inversely proportional. ये सब आप ग्राफ्स जो हैं पीछे एक बार जाएं तो देख सकते हैं. अब ये है अदर थिंग्स, फ्यूचर के लिए हमें और क्या कंसिडर करना चाहिए. We may consider imperfect items if in our production or transportation some items are suppose destroyed और some उसमें कुछ खराबी आ जाती है, तो उसके लिए भी imperfect items को भी हम इन्वेंट्री मैनेजमेंट में हम कंसीडर कर सकते हैं. एंड imperfect आ गए तो imperfect items को हम क्या करते हैं, रिवर्क पॉलिसी, और if we replace the imperfect items, then the concept of human error, that the human errors, if the item is not imperfect and we declare that is imperfect, that is also human error. If item is imperfect and we purchase that item, that is also human error. So that also can take in consideration into the inventory modeling. Advertisement, shortages are not taken into this model, but shortages may also occur. So that may also taken into consider. Another thing, carbon emission in supply chain. And you know that UN का जो 2015 में सबमिट हुआ था उसमें 17 या कुछ गोल्स बनाए थे सस्टेनेबिलिटी के लिए, तो उसके लिए कार्बन एमिशन बहुत, तो these days every industry, द ट्रांसपोर्टेशन हो या आपका मैन्युफैक्चरिंग हो, देयर इज कार्बन कैपिंग इज देयर, तो कार्बन कैपिंग की भी कॉस्ट होती है, दैट इज ऑल्सो इन्वॉल्व दीज डेज एंड that is all can also be considered. So how we can reduce the carbon emission, there is study, and these are the references. And for this, if in my our one paper or 2 or 3 paper we use carbon emission sustainability, and you will wonder that all 3 papers came into cleaner production, that is 11.2 impact factor is there. एंड एक पेपर जो जनवरी में आया था 2022 में, और उसका साइटेशन 44 है, अभी ये दिसंबर चल रहा है, मतलब 12 इतने इंपॉर्टेंट है कार्बन एमिशंस। और ये जो है हम आगे के जो मॉडलिंग करें, इन्वेंट्री मॉडलिंग, तो हमें जो रियलिस्टिक पैरामीटर्स हैं, वी शुड कंसिडर दोज मॉडल्स सो वी कैन गिव समथिंग टू द ह्यूमैनिटी। थैंक यू। दो कौन से बताए मैंने? अच्छा, मॉडल और ऑर्डर कॉर्ड, उसमें ईओक्यू में हम क्या होता है, प्रोडक्शन को कंसिडर नहीं करते, हम मैन्युफैक्चरिंग यूनिट नहीं है, हम केवल क्या कर रहे हैं, हम कहीं से खरीद के ला रहे हैं। जैसे मेरी गांव में दुकान है, आउटसाइड बिटवीन ईओक्यू उसकी कैलकुलेशन कोई डिफरेंस नहीं है, आप डिफरेंट और थैंक यू।
I request CV Gupta sir to present certificate and memento to Salah ma'am.
Now I am
So our next speaker is Professor CV Gupta sir, and I request Salah ma'am to chair the session. So CV Gupta sir and Salah ma'am, please.
We are exchanging the chair. Right?
Actually, now I am honored to introduce Professor C.B. Gupta. Professor Gupta is presently working as Professor of Mathematics, Director IQAC and Chairman NAC, the North Cap University, Gurugram. Previously, he was in BITS Pilani, and our association since those days,
Very long.
And many researchers have done their research under his supervision in different areas, not 2 or 3 areas. He has vast spectrum of areas. And one more thing we share, that basically we both are statisticians. So that is the common thing. And
Yes.
yeah. But statistics is also mathematics. And it is all, when I define statistics, I say it is science of observations. This is my definition. So now,
Thank you, ma'am, for nice introduction. In fact, Professor Sarla Parekh told that statistics is the science of observation. But I define statistics in a different manner altogether. First of all, I feel sorry to all mathematicians because the definition which I am going to tell, many mathematicians feel offended. So I define statistics, that statistics starts from the point where mathematics fails. Means, doesn't mean that mathematics has failed there and there is no mathematical terminology or formula or application cannot be used. But when in mathematics we are not able to find the solution of a problem, we gather data what Sarla Parekh told and analyze it up to 5% or 10% maximum error, which she defined type 1 and type 2 error in her lecture as well. So thank you very much, and the topic is very vast. That international conference on real world challenges and inferences in mathematics. Tools and strategies. So friends, when the word domain and inferences are joined together, tools and strategies have been come there. At any platform, we have no reason to combine mathematics and statistics together. They cannot be separated. And rather, no one can separate mathematics and statistics. It's a mathematical science which deals with pure applied optimization, operation, decision analysis, and statistics, etc., etc. So keeping in view the real world domain and inferences, today I have chosen the topic to talk about modeling of male at marriage evidences from Western Uttar Pradesh. Friends, in India, not only in India, across the world, all of us talk about the marriageable age of a girl. We never talk about the age of a man, though it is very important. We always talk about childbearing age of a girl. Because in India, from the very beginning, we talk about that every girl has a dream to have a good husband at her youth age. We never talk other way around. सपनों का राजकुमार चाहिए, किसी को सपनों की राजकुमारी नहीं. We never talk like that. Because still in India, childbearing outside the marriage is not recognized. It is considered unrecognized act or a sin. But marriages are going on. Earlier, the marriageable age of male and female was 21 and 18 years. But last year in 2021, central government passed a bill in Lok Sabha and Rajya Sabha, and the marriageable age for the male and female have become 21 now. The reason why we have studied, this paper is already published in International Journal of Statistics, published from USA. It's a very high impact factor, and it's along with my student, Mr. Sachin Kumar, who is working in England nowadays as an associate professor in statistics. And the data which we collected It is from Western Uttar Pradesh district Meerut. The reason of choosing the reason that in Uttar Pradesh, Western UP, in particular Meerut, is a hub of education. They are well versatile with politics and they are very much economically sound also. So keeping in view the society norms also, we thought let us study the male marriageable age. How does it affect? Because still in society, we consider that male are more educated, they have power of decision, family is dependent on that, though this should not be in today's scenario. We go hand to hand with female, but still it is a thought which should not be. Okay. So the outlines, what is the objective? Abstract data collection methodology, frequency distribution, very simple, some statistical measurement, which model we have done, parameter estimation, chi-square distribution, determinants of age at marriage, conclusion, and references. The objective of this study is nothing, to propose a new model explaining the male age at marriage. The second objective is to investigate the determinants of age at marriage through Cox proportional hazard model. It is nothing, it's a regression model only. The abstract, we have made an attemptation to develop a continuous probability model under some assumption to explain the pattern of male age at marriage. Some statistical measures were also used to understand the nature of data, and expectation maximize algorithm is being used. We have determined the role of various factors on age of marriage, and Cox hazard model is also applied. As I mentioned, the data which we collected, it is from district Meerut of Western Uttar Pradesh. The reason I explained. And it's a primary data. Personally, we have gone door to door. 3,300 households have been visited from 3 different categories, means from each category we collected data from 1,100 households in person. It's a primary data, no secondary data have been used. If you see this, the total data have been taken from 3 categories, which we define it semi-urban, remote, and growth centers. Semi-urban means the villages which are within 8 kilometers of Meerut Nagar Nigam. Remote is outside this, and the growth centers, the nearby villages of the industries and the sugar mills, etc. 3 categories. And the further these villages have been divided into large, small, and the middle kind of villages. This is what I have told. So from each category, I mentioned already 1,100 households have been. Now, when the data was collected, the frequency distribution have been computed. According to education, there are 23% males, 48.5% secondary, and 28.5% above secondary, which includes graduate, postgraduate, PhD, MBAs, etc., whatever it is. Similarly, they have been divided into occupation-wise. Labor is 39%. The agriculture dependent, around 41%. And others are 20%. Family size is small, which has 3 or 4 members. Similarly, the middle size, 5 and 6, and the large size above this. That is the 14, 45, and 40%. Hindus are 83%, non-Hindu, or in that Mera district. Very few, maybe 1 or 2 houses is Christian and all this. But other than Hindu, we have taken together, means the Jains, Buddhism, they all have been categorized as Hindu, and other than this have been categorized as Muslim, only 2 categories. Then villages are, I explained, 3 types of semi-urban, rural, and the growth centers. 39% and 20% near the. So we have computed their mean and standard deviation. If you see, 23.59%, or you can say it is not the percentage actually, it's the age of males is coming out 23.59 years if they are primary. If they are secondary, then age has increased 24 point this, and if they are higher education, that more than 25 years. Similarly, labor 25, agriculture 24.09, and other than this 25.32. Maybe one of the reason could be here. When we talk about the early marriage or something, that still we have a concept in poor family that more the hands, more will be the earning. So if there is early marriage, the child bearing will be early. And if marriage is delayed, then the fertility will also be delayed. So based on that concept, it could be one of the reasons. Similarly, the family size, if you see, if it is a small size, the marriage took place at around, on an average, 26 years, but it decreases according to middle size and the larger size. In Hindus, on an average, the marriageable age is 24.56, and in Muslims, it is around 23 years. Semi-urban, it is 24.30, and remote villages, it comes down 24.08. But if you see suddenly, nearing the industrial area, the age increases, because they have a lot of prosperity and all these things. So they first want to settle down and then wants to go for marriage. So model which we have taken, here all the individuals of this is at marriageable state, and let X be the age at marriage. 2 groups are there with probability alpha and 1 minus alpha. We have considered the logistic distribution with probability alpha and 1 minus alpha. This is the probability density function. I am not going into detail. If somebody is interested, please can contact me. Its mean is mu and variance is 1/3 pi square s square, where s is a standard deviation. The expectation maximize algorithm is considered over here. Given the current parameters and the observed data, we estimate the latent variables, and then again it goes back and we use the latent data and observed data and then estimate the parameters, and this procedure keep on going unless the parameter stabilizes to a point. Stability, and we find out that mu1 is 23.86, mu2 is this, standard deviation and standard deviations are like that. The probability is 0.90. Now, the observed and expected frequencies between 18 to 21, the observed frequency was 44 and expected frequency is 40. And you see it's very close observed and expected frequency when it was computed. And we have seen the chi-square test of goodness of fit, which comes out to be 2.80 and p-value is 0.73. Then determinants which we have computed, it is based on the Cox model, which is STZ is equal to H naught T, exponential beta 1 Z1 plus beta 2 Z2, etc. Beta is nothing, it's a regression coefficient which we will be estimating. In fact, this table is most important. I just want to highlight this table. When we have estimated according to this Cox model, and we make base 1, if you see the last column, 1, means it is taken at base 1. And comparison to this, in primary last column, it is 1.570. This gives that in comparison to a male who is highly qualified, there is 57% more chances that he will be married early. 1.57, 57% more. Similarly, for a person who is past secondary, has 32%. Similarly, occupation-wise, the labor has around 29% more early to get married, and agriculture person has 27%, 1.270. And according to family size, if we make a basis to large family, then there is almost 50% chance of early marriage into this. It means he will get married at a higher age. Similarly for middle, 82.9. Religion, if we make base to Muslim, then 77% less chances are there for Hindu. Okay. 1 minute only. Similarly, if you make chance to growth center, then early marriage chances of semi-urban is 13% more and 2% for remote. So this I have already explained. Mixture of logistic fully justifies the age of marriage pattern of the study region. One group prefers early marriage while the second some other priorities before setting in life. Educated males tend to get married late as compared to the lower educated male. Family size has been found to play a crucial role, and religion also. Very important role is marriage related. These are the references. Thank you. Any query or questions? Yes.
Thank you, sir, for giving a talk in the hot topic of these days, that what is the marriage age and what should be, and what are the factors and all. So I think this type of study we can do anywhere. This was done in West UP. We can do in Rajasthan. If we change the district name, then another district. So this study is giving so many.
But pattern will remain almost
Same. So we can see that.
This I have done. One study I have comparison with Kerala and Rajasthan. If you see the scenario, the totally Kerala is different from Rajasthan. But the result is sad. Our theory says it is almost same everywhere at all.
I request Salah ma'am to present certificate and token to Professor C.B. Gupta sir as a token of memory.
जब मैंने बीएससी केमिस्ट्री से करने के बाद एमएससी में फॉर्म भरा तो मैं फिजिक्स और मैथमेटिक्स में ही भरा था। फिजिक्स में नहीं आए तो मैथमेटिक्स में हो जाएगा, लेकिन फिर ये हुआ कि ये देना है तो फिर स्टैटिस्टिक्स में किया और मैथमेटिक्स में मेरा टॉप पे नाम था उस समय। और मैथमेटिक्स उस मेरा मतलब बहुत अच्छा स्कोर होता था, लेकिन वो उस समय का जो मैथमेटिक्स का लव कह सकते हो या आप वो कह सकते हो कि अगेन इन टर्म्स ऑफ द रिसर्च एंड in terms of heading the department of mathematics and statistics that came to me. So I think that is the blessing of God for me. So, and visiting the mathematics department as a guest speaker, that is very naturally, I'm feeling very honored.
Thank you, Salah ma'am, and thank you, C.B. Gupta sir. And now, yes, of course, yes. Coronavirus. Yeah.
आपको मैथमेटिक्स डिपार्टमेंट के बहुत सारी ऐसे कभी काम किया है, एक मेरी स्टूडेंट भी है।
Now we will have a small tea break and no. Okay, then no problem. Tea will be there in the hall and other venues, and I think very soon we are going to start paper presentation session. So be prepared.
Good evening to Professor Carla Pinto, and welcome to you. Now, next session is of Professor Carla Pinto from Portugal, and the session will be chaired by Dr. Om P. Sutar sir. Now, I invite to Professor Om P. Sutar to start this session. Please, sir.
Yeah, so good evening, one and all present. It's my privilege to introduce Professor Carla Pinto, who is the speaker for this session. Professor Pinto is a coordinating professor in the School of Engineering Polytechnic of Porto, Portugal. She has a PhD degree in the scientific area of mathematics since in January 2004. Her main research topic is epidemiology, in particular mathematical epidemiology. She is interested in mathematical challenges and their role in providing advice on public health policies. Professor Pinto is trained in nonlinear dynamics and bifurcation theory. Previous research of her includes the analysis of central pattern generators for animal and robot locomotion, coupled cell networks, neuron-like equations, etc. She is a guest as well as associate editor of several international journals, member of scientific committees of international conferences, She has published more than 165 papers in international journals of repute as well as conferences. She has been cited more than 1800 times, and she has an H index of 21. So it is really an honor for us that she is here to share her research with us. The topic of her, the title of her talk is How HIV Infection Undermines the Islets of Langerhans Beta Cell Function in T1D. So with this, I request Professor Pinto to start her presentation. Professor Pinto.
Can you see my screen?
Yes, ma'am. Yes, ma'am, it is visible.
Thank you. So
Yes,
I start by thank you very much the organizers for this kind invitation, especially in the person of Professor Devendra Kumar, my colleague and friend. By now, I think I also can call him a friend. And so this is an honor to be here with you and to share some of our results. In this case, is the relation of HIV infection with the development of type 1 diabetes in patients which are already recovering. So they have antiretroviral therapy. They are under antiretroviral therapy, and they are already recovering the healthy number of CD40 cells. So I'll start with a brief introduction relating. So giving a few a few topics concerning the epidemiology of HIV and T1 diabetes, because I think that that you can only understand and you can only develop a correct epidemiological model if you really know what is the epidemiology of the diseases that you are modeling. So if you don't know any of the biology of the diseases, then it's really quite hard to know and to get some inferences from the model, right? Because you don't know how to comment your results. And so, as you know, HIV/AIDS has been one of the major burdens in terms of diseases of the world. Why more than 1 million people die annually due to this disease. And we also know that it's now a chronic disease. So people who are infected for life. But we have antiretroviral therapy, which helps people have a better quality of life. But anyway, there is still no vaccine, and we know this disease since the 1980s. So there is still no vaccine available to prevent the development of the infection, and so it's still a chronic disease. What is the relationship between HIV and diabetes? Type 1 diabetes. We all know that there is type 2 diabetes, okay? But in this case, we will refer to type 1 diabetes. And so, as you know, we need very much the beta cells, which produce the insulin in order to for our body to get the glucose that he needs from the food that we ingest. And when these insulin-producing cells, which are the beta cells, they are destroyed by our immune system, it's called an autoimmune disease. And the person who has HIV infection develops T1D. This is not a very common, we know that, but there are people, from young people to older people, that develop T1D after being after starting to recover from HIV infection. So after starting antiretroviral therapy. This is also related to to Japanese people. So it's more common in Japanese people that this occurs. So HIV people, Japanese people who are infected with HIV and then treated some of them developed T1D, which is an autoimmune disease. So this phenomenon has been seen in several patients recovering, and the most recent was in 2020, an older African American man who has developed the diabetes 1, type 1 diabetes, when he was already starting to recover after the antiretroviral therapy. So our model is a within-host model. It includes the first part of the model. So the first three equations are related to the HIV infection. So we have the CD40 cells, we have the infected CD40 cells, we have the virus, HIV virus, and we have then the macrophages, the activated macrophages, the infected macrophages with HIV infection, and then we have the beta cells, which are these two. We have the apoptotic beta cells, and we have the the necrotic beta cells, which are the ones that die due to the effect of our immune system. So our immune system destroys these beta cells. And these are the cytokines which are involved in this immune cell destruction. So this is a schematic model, schematic diagram of our model. As you can see, the CD40 cells are infected by HIV. They are also they influence here, around here, the cytokines, and they go and kill. They send information so that our immune system kills the apoptotic beta cells, which are extremely important to regulate the blood glucose level. So without these cells, we develop T1D, and you know, one of the consequences of T1D, if it's not, if the patients do not take insulin, is that they die, right? So that's the most dangerous consequence. So we have studied the qualitative properties of this model, and there is for every unit normal vector of the boundary of this non-negative non-touch, we have a right to obtuse angle against the vector field, and so all of the non-negative trajectories proceed to non-negative values, and we computed 4 different equilibria. One equilibrium is the disease-free equilibrium. Then we have the HIV-free equilibrium. Then we have the T1D-free equilibrium. And then we have the coexistence equilibrium. And so in order to study the stability of the equilibrium, we computed the Jacobian matrix of the system. And so we obtained this 9 times 9 matrix. And these are all of the coefficients there. And it's quite obvious that the disease-free equilibrium is stable under certain conditions. And the conditions are that this number here is less than 1. As you can see, the death rate, the clearance rate of the virus is important, of course, to reduce that value. We can call it reproduction number. And if you have more infected cells, then you have a major burst, and this increases the reproduction number. So all of these, you can do here the sensitivity analysis, and all of these parameters are completely understood from an epidemiological point of view. So if we have this value greater than 1, then of course we will have an endemic state, either if it's only an HIV endemic state or T1D endemic state or a co-infection endemic state. And so we have done all of these studies using the Jacobian matrix of stability theory and local stability theory. And then we proceeded with the numerical investigation. And so we have done some how do you say, we have normalized the cells numbers, and then we computed the outcomes of the model. And as you can see here, there is a bump in apoptotic beta cells, which coincides with a bump in the number of cytokines. And this happens right after the number of virals starts to decrease. So here, it's the suggestion given by the model that when the T cells start to happen. So our model predicts that when you have an increase in the C cells, then afterwards an increase in the necrotic beta cells. This happens when the T cells are increasing, so the patient is recovering, and when the virus in the body is decreasing. So here it is an evidence of our model that in fact T1D may develop after immune restoration. And so we have computed the bifurcation diagrams associated with these. And we have different bifurcation points. And here in this area, you can see that there exist both T1D and HIV at the same time. And this happens in a region where the number of virus, the viral load is less. Okay, so it's here you can see that noisy. So here you can see the bifurcation diagram, a closer look, where you have a T1D free area region, which is in yellow. Then in red, you can see the coexistence region from T1D and HIV. And then in blue, you can see the HIV-free region, but you have the type 1 diabetes established. So after this T1D is an immune disease, autoimmune. Okay, it's not caused by any virus or etc. So what we're trying to show here is that if you're a patient with HIV, in some circumstances, you can develop T1D when you start recovering from HIV infection. This is what is shown in this within host model, this cell model. So here you can see the three different solutions. The yellow is when you have T1D free. The blue is when you have HIV free equilibrium, and the red is when you have co-infection equilibria. And so this is the first model that we could find in the literature, mathematical model, that really shows the dynamics, the patterns related to the development of type 1 diabetes in HIV-infected patients. So there is no other paper that shows this. There are a lot of papers with type 2 diabetes, but type 2 diabetes cannot be explained by any of these dynamics of the HIV. Type 2 diabetes may be due and is related to the antiretroviral therapy, in the sense that since it's still very toxic for the HIV infected patients, they end up to have a disturbed immune system related to that, and then they develop T2, so type 2 diabetes. So it's not the same thing, it's a completely different phenomenon. And so as we have done numerical simulations, vary the efficacy of the antiretroviral therapies, the protease inhibitors and the reverse transcriptase inhibitors. And we could show that there is an association between the taking of the antiretroviral therapy and the killing and the deletion of the beta cells by our immune system. Of course, we would need to have clinical trials specific to this in order to be able to set more specifically and estimate more specifically our parameter values. But as I've told you, this is some of these rare events that happen in HIV infection, and it's quite hard to set up a control group because in the other group you may not find anyone which develops T1D. So it's quite hard to establish such a clinical trial. So I end up saying that just like George E.P. Box, who was a statistician, he said that all models are wrong, but some are useful. And this is what we intend to do with our epidemiological models, to provide some insights, to be as accurate as possible with respect to the epidemiological part and mathematics, of course. But anyway, these are just models. If it was too complicated, then it would be real life, right? And so, as you know, in modeling, you have to think of the pros and the cons. If you have a very big model, then you cannot do the math. And if you have a very small model, then usually you cannot take any predictions from it to real life. So it's something between an equilibrium, again, just like everything in our life has to be an equilibrium. So these are some of our references. The first one is from this study, and it was published in Chaos, Solitos, and Fractals. And then you have other references concerned with epidemiological models. You can see more of these in my ResearchGate or guide or my website, personal website, or you can send me an email to this email address here, cap@iscb.ipp.pt, and I will be glad to reply to any of your comments or suggestions or whatever. So again, I wanted to, before the questions or remarks, I wanted to thank again Professor Devendra Kumar for his kind invitation. I want to congratulate all of you for the organization of this conference. And so now I'm available for questions if you have any. Thank you so much. I'll stop sharing. Thank you.
From the participants, you can ask. Yeah, meanwhile, if they think, I have a question that you have shown us a dynamical system which was having several equations. And
Yes.
you have also presented that there was a bifurcation at some point. So I have a couple of questions. First thing is it that what type of bifurcation it was? First thing. And is there a possibility of having several bifurcations later on? So because you have shown only one bifurcation in that model.
We have 3 bifurcation points, and these are just bifurcations to another equilibrium. So it's not hot bifurcation. It's how do you say? Oh, I forgot the name. It's one of those easy, not easy. It's a bifurcation from one equilibrium to the other. So the first equilibrium was stable, so all eigenvalues have values negative were negative, and then you change for another region, and that equilibrium, who was, for example, a T1D free equilibrium, lost stability, and then another equilibrium gained stability. Okay, so you move from type 1 diabetes free equilibrium, so the person has HIV infection. Then as you increase the antiretroviral therapy, you get the co-infection equilibrium, which means there is this small region, red region, in which you have T1D coexistence with HIV. And then if you increase a little bit more, so the parameter values are both the antiretroviral efficacies, both the two of them. And then if you increase a little bit, then you move to a perimeter region in which you have another branch of equilibria, and which is HIV infection-free equilibrium. So it's free in the sense of mathematics, but as you know, someone who is infected with HIV won't be cured. So there's always viral load, but it's below the 50 copies per milliliter of blood. And so you can consider in those conditions that the person mathematically doesn't have HIV infection. But epidemiologically, he or she will always be infected with HIV, except for the people that are called elite controllers, which may be infected with HIV, but they have some mutation in a protein in their CD4 cells, which allows them to fight the virus. Oh, it's not to fight the virus, which allows them to be protected by the infection of the virus. So they don't allow the CD4 T cells of these people, don't allow HIV to get in the membrane of the cell to adjust to the membrane of the cell. And so the virus cannot proliferate. And these are called elite controllers, but we only have 10% of the people like this. So 90% of the people who are infected with HIV will always have HIV. It's a chronic disease. Okay, yeah. So we have this difference here between the mathematical model and the epidemiological meaning. Okay.
Yeah. Thank you. Thank you, ma'am. Any other question? Any other question from the audience? Okay, if there are no questions, then let us thank Professor Pinto for a nice illustrative talk on which includes dynamical system and its analysis for a very practical problem which is there in real world. So like one of the slide, I think amongst the last slide, it said that all models are not wrong, but some models are useful. So on that line, it was extremely useful talk. Thank you very much, ma'am, for such a nice talk.
Thank you. Thank you for the kind invitation. Thank you. And congratulations on the conference.
Yeah, thank you, ma'am. So we have, as a token of thanks, we have a memento and a certificate for you that will be shared with you online, ma'am. So please, thank you very much. Thank you very much, ma'am. So this is.
Thank you. Thank you. Yeah. Thank you so much. Thank you. Thank you. You are very kind. Thank you.
Thank you very much, ma'am. Thank you.
Thank you. Bye-bye. Thank you. Thank you, Professor. Thank you.
वीडियो ऑन करूंगी ना तो मेरा मुंह आएगा तो तुम्हारा भी आ जाएगा। नहीं हाँ कहीं भी आ जाओ या घर बैठे।
आप अपना लड़ाई आपको वो कहेंगे रिक्वेस्ट आएगी अभी आपको
दोबारा स्टार्ट वो जोड़ Good evening. Next session is Dr. Deepa Sinha ma'am. She will deliver his talk now online, and the session will be chaired by Professor Presh Vyas sir. Now I hand over this session to Professor Presh Vyas sir.
Very good evening. Am I audible? Am I audible? Am I audible to you?
Yes, sir, you are audible.
Okay. So our next speaker is Professor Deepa Sinha. She is a professor in South Asian University, Delhi, and she received her PhD from Delhi University, India, in applied mathematics in the year 2007. Earlier, she did MSc in mathematics from Indian Institute of Technology, Kanpur, in the year 1994. And since then, she has been serving several institutions, particularly Khalsa Girls Degree College from 1996 to 1999, Delhi College of Engineering for the period 1999 to 2004, Vanasli University 2004 to 2012, and Delhi Technological University 2012. She has guided many students in discrete mathematics in MSc, MPhil, and at PhD level. She has guided 14 PhD students and 7 MPhil students. She is principal investigator to the project sanctioned by DST SERV under Matrix Project PAC Mathematical Sciences. She has refereed several research papers for national and international journals of high impact factor. She has organized, coordinated more than 30 workshops, training programs, and conferences. She has delivered several lectures as a resource person and invited speakers at different places in India and abroad. She has reviewed one book published by Taylor and Francis. She is a member of 5 reputed Society of Mathematics and the fellow of ICRWDIM ACS. Professor Sinha would be delivering her lecture on the topic encryption and decryption of signal graph through RSA algorithm. I welcome you, Professor Sinha, to deliver your lecture. Professor Sinha, are you listening to my voice?
Am I audible?
Yes, ma'am.
Okay.
Now you are audible.
Okay, thank you. So is my screen shared? Are you able to see the screen?
Yes, ma'am.
Okay.
No,
Ma'am,
not
your
right now.
screen is not visible.
Screen is not visible? Okay. So just a second. I was able to see all your screen. Now what happened, I don't know.
Still not, ma'am.
Still not? Yeah.
No.
I'll just restart and do it, okay? Just give me a second.
Okay.
सर मैं नहीं कर रहा हूँ वो है वहाँ पे कोई ठीक है अगर कुछ टेक्निकल होता है तो मैं Now visible, ma'am. Not visible.
Okay. Then I will just Is it visible now?
Yes, ma'am.
Okay, okay, thank you. So thanking Professor Vyas for such a nice introduction and all the organizing team members, and congratulations for organizing such a wonderful conference on a very special topic of mathematics. So I will be on that line. I will be speaking on sign graph application to encryption and decryption. So it will be my talk will be organized as follows. It will be followed into first part will be introduction, and the second part will be the encryption and decryption of sign graph through RSA algorithm. So encryption and decryptions have been major research many work has been done in encryption and decryption, but then those are very much, in the same direction. Okay, generally by image or image processing, video processing, and all that. But now I am going to present the encryption and decryption using the graph theory method, graph theoretical method, especially sign graph. So some of the work has not been done in this direction using sign graph, but then not much. So in the introduction, so I will just start from the basic things and then I will come to the main topic. So the introduction will be containing the terminology, notations, and other things. Okay, and it gives the glimpse of major problems tackled or directions of the research followed. So as we all know, a graph is made up of vertices and nodes, and lines called edges. So this is basically the collection of the entities and how they are related to each other. Once they are related, they will be joined by line. So the line is discrete. It need not be with the usual analytic functional with the function mapping. It is just that they are related to each other. So it can be, entities can be whatever we are modeling, that can be our entities, and how the one entity is related to each other. So they will be joined by a line, and this is basically in mathematics, the entities will be called as the vertices, and I also will be calling it as a vertices, and then and the lines will be called as an edges. Otherwise, in computer science, they call it as a link. So this is the example of the graph. And then sign graph is nothing but it is the graph where the edges are given the weights plus and minus. So if they are getting the weight plus, then it will be denoted by a bold line. And if they are getting the weight minus, then they are denoted by the dotted line. So like here the three things can be discussed simultaneously, either whether they are related to each other or if they are related by one factor. So these are related, 1 and 3 are related by one factor, 2 and 4 are related by one factor, or they may be related by another factor. So three kinds of things can be seen simultaneously, whether they are related or not, and if they are related, where they are related by factor A or factor B. Okay, so this is what is the sign graph, and it has got huge applications. So I will not go into that, seeing the limitation of time. But yes, so I will be also using the algorithm, and which is algorithm is a procedure or a formula to solve a problem, and that everybody knows. And it derives the word from the name of mathematician Muhammad Musa al-Khwarizmi, who was a part of the royal court in Baghdad and who lived from century 780 to 850. In mathematics and computer science, algorithm is a step-by-step procedure for calculations. Algorithms are used for calculation, data processing, and automated reasoning. So basically, if you give anything and support it by algorithm, so it becomes more, if it seeing its complexity, it can be used for the application in the manner it can be applied to the model in which the researcher is working. So now, once we are using the computer system, there are different ways to store the graphs in the computer. the data structure used depends on both the graph structure and the algorithm used for manipulating the graph. So again, it will depend on the type of modeling that we are going to do with the entities or the vertices that is with us. So theoretically, one can distinguish between list and matrix structures, but in concrete application, the best structure is often a combination of both. List structures generally are preferred because it acquires a less space in the computer, but matrix representation requires can consume huge amount of space and memory. So, but then it depends again that what will be the best suitable choice according to the model. So adjacency matrix of the sign graph. So what is that? So we are going, because in the computer this graph can be stored as in the matrix form only. So in our case we are going to use the adjacency matrix. So what is the adjacency matrix of the sign graph? Suppose if it is denoted by S, having n vertices v1, v2, vn, and of course no parallel edges, that will be represented as the matrix n cross m with the entries aij, I varying from 1 to n and j also varying from 1 to n, and aij may take the value -1, 0 or 1. If the vertex vi is adjacent to vj, it will take the value 1. If the vertex vi is not adjacent to vj, it will take the value 0. And if the vertex vi is adjacent to vj with a minus sign, then as we have seen here, okay, so this is 1 and 2 so there will be 4 vertices and one for 1 and 2. So A12 will be represented by -1, A14 will be represented by -1, and A41 also will be represented by a -1 because it is a symmetric matrix, and A31 will be denoted by +1, but A32 will be denoted by 0. So that is the adjacency matrix of a sign graph. So now we come to the topic, like introduction of the topic, graph theory and cryptography. So secret communications have been needed by military officers, diplomats since ancient times. So like in the case of the military, like even cops can use this. So what happens that if they want to, if there is any chaotic area in some place, like in Russia or in Ukraine or anything of like that, and if you want to place the cops or the armed people in the places such that the vigilance is of the military attack is there, in that case what we do, so what the master man sitting at his own station may design the structure where the people, by using the graph theoretical method, using the graph or the sign graph, where the people can sit, and then there, and it has, so this cannot be, this should not be vulnerable to everyone to attack. That is, it should, once we send this information that these are the placings where the people are going to sit, or the cops or the armed people are going to make a bumper or wherever they are going to sit. So in that case, this technology, this has not to be disclosed. So there should be some kind of encryption done, so that the message is transferred to the people placed over there. It does not get disclosed to the or it is not vulnerable to attack, So in today's advanced age, where the internet, mobile phones, and computer technology are widely used in almost every sphere of life, the need to keep important information secure and confidential is also increasing day by day. So people have been, I told you in the beginning, that many people have been working in this area, and they just try to give the encryption or decryption, encryption with little more increment in already existing methods. of encryption, decryption, or cryptography, where mostly the image processing has been used. Okay, so here, and I'm going to use the sign graph, but maybe this also become obsolete with time. Over time, as data security continues to evolve, new ways to break the confidential communications are being discovered, as I was discussing. The cryptography is a study of changing restricted information into coded data so that can securely arrive at its end without spillage. It was fundamentally used for wartime plans. Earlier during the wartime, it was used. Again, the same, the issue was same. Old style cryptography revisits after 2000 years. So modern cryptography is highly connected with discrete mathematics. Many cryptographic algorithms are directly based on mathematical results. So what is cryptography? It's basically the scientific and practical activity associated with developing of cryptographic security facilities of information and also with argumentation of their cryptographic resistance. And cryptanalysis is the analysis of cryptographic algorithm with goal to obtain estimations of their cryptographic resistance. That is how much resistance or how much good this is. The method is. And cryptology is the concept combining both cryptography and cryptanalysis. So, and what is encryption and decryption? The process to transform the original message into a code format is called the encryption, and reverse process is called decryption. Plain text is a non-encrypted message with the help of specified key, and plain text information is encoded, that is encrypted, to generate ciphertext, which is in any encryption technique. So the main focus in this lecture is on the development of a new cryptography mechanism for secure data transmission and retrieval using sign graphs with adjacency matrix and using RSA algorithm. And this concept is implemented on network of cities, any cities. Here it is worked on city of Afghanistan to make it more secure network. So what is RSA algorithm? In 1977, an algorithm was developed by Ron Rivest, Adi Shamir, and Leonard Adleman, and was the first publicly known example of a secure practical algorithm, so that on their name it was called as an RSA algorithm that could be used to encrypt secret messages without establishing a secret key beforehand. As a public key cryptography system, RSA algorithm calls on intended recipient of an encrypted message to create a public and private key. It publishes the public key, which anyone can then use to encrypt message to him, and keeps private key secret. So the RSA algorithm, public-private key pair generation, that is based on difficulty of factorizing large integers. And this work can be seen in Nisha S. and Farik M. in International Journal of Scientific and Technology Research in 2017. For generating, this is the algorithm. For generating public key, so select two prime numbers P and Q and calculate N is equal to P into Q. Then choose a number E such that E is an integer and it is prime to this number capital N, and G's greatest common divisor of E and N must be equal to 1. And also E must lie between 1 and the totient function of N. That is, so then the public key will be equal to E and N. E is the number which you have chosen, which has such a kind of quality. So, and for generating private key, calculate the totient function phi n, which is equal to P minus 1 into Q minus 1, and calculate the value of some in D such that D into E mod of phi n is equal to 1. So we need to calculate the value of D such that D into E, which we have calculated earlier, into reduced modulo phi n must be equal to 1. then the private key will be equal to dm. So public key is equal to en and the private key is equal to dm. The public and private keys both are used for encryption and decryption respectively. Based on the concept of sign graph, adding more security to a network, an effective mechanism is designated for encryption and decryption of matrices through sign graph by RSA algorithm. So now let us come to how are we going to use the sign graph. So let the adjacency matrix of the sign graph with n vertices v1, v2, vn without parallel edges be represented as aij, where aij is equal to may be equal to -1, 0, 1. Already explained this for j and I equal to 1 to n. The adjacency matrix related to sign graph is always symmetric, already discussed earlier. And due to this characterization, the upper triangular matrix U and the lower triangular matrix will be transposed to each other. So upper triangular matrix will be U and the lower triangular matrix is denoted by L. So U and L transpose will be same. So now the proposed mechanism is, let this be an adjacency matrix with respect to the graph or the sign graph. Upper triangular, lower triangular matrix is enough to recognize the adjacency matrix. So as already told that the matrix takes lots of memory and space in the computer. So we will just concentrate on the upper triangular or lower triangular matrix. So let us consider only upper triangular matrix for encryption and decryption mode. So I am at present considering upper triangular matrix for encryption and decryption process. So first write all the elements of the, so this is the method how are we going to proceed. Write all the elements of the upper triangular matrix as a number with starting from the last row of the upper triangular matrix, and for each row the direction of the writing should be from right to left. I will be explaining it through the example, but just for the methodology, I just go through the method, how it has been done. So number of digits in this number will be equal to n square minus n by 2. So total number of elements in the adjacency matrix is n square. And what we are doing, we are omitting the diagonal matrix and only taking the lower triangular matrix or upper triangular matrix. So that means the number will be n square minus n divided by 2. And n is the number of vertices in the sign graph S. Now every -1 will be considered as a decimal itself, and the rest, which is the string of 0 and 1, which we will see in the example which I have done, which will be followed. There will be a string of numbers 0 and 1, which will be separated by -1. So this will be considered as a string of 0, 1 will be considered as one decimal number, -1 another decimal number, and then another string of 0 and 1 will be another decimal number. Binary number. Sorry. The string of 0 and 1 will be considered as a binary number, then separated by -1. So -1 will be single decimal number, and then another string of 0 and 1, which followed by -1 will be another string of another binary number. So in the next step, we add 1 in the beginning and end of every binary number and convert all the binary numbers into the decimal numbers with -1 as such. We will not change this -1 because we are taking -1 already as a decimal number. Thus, we are having a string of decimal numbers D1, D2, Dk, K varying from 1 to R. It cannot exceed R. So these will be the string of 0 and 1. So for encryption, the values of D1, D2, Dk are encrypted by applying RSA algorithm to get the encrypted numbers, that is alpha 1, alpha 2, alpha k. Instead of D1, D2, Dk, we will be converting it by using RSA to alpha 1, alpha 2, alpha k. And of course, k will vary from 1, k will be greater than 1, but less than equal to R. And this ciphertext is sent to the receiver, who can derive the original matrix by applying the reversal process. For decryption, after receiving the encrypted values, that is ciphertext, it is decrypted to get the values of D1, D2, Dk, k varying from 1 to R. 1 strictly greater than 1, less than equal to R. And for every DI 1 to K, except for -1, it is converted to binary numbers. That is, it will have to be decoded because it has to come back to the matrix, and then from matrix it has to come back to the graph to construct the upper triangular matrix U. So the order of constructing the matrix is row wise. Here the first most digit represent the last entry of the top row to the last row. And by continuing this process, the upper triangular matrix is derived. The lower triangular matrix is constructed by getting the transpose of the upper triangular matrix, and the adjacency matrix of given sign graph is produced by putting them together. So these are the algorithm. Input is you put the adjacency matrix, output is numerical values D1, D2, Dk, and step 1 number of rows in capital A. Step 2, I is equal to 1, then 2.1, j is equal to 1, aij will be equal to 0 because this is a symmetric matrix with the diagonal and with no loops and parallel edges, so diagonal entries will be equal to 0. So a11 will be equal to 0, 2.1.2, j will be equal to j plus 1, and so forth. So, and if I is less than n, then go to step 1, else return to upper triangular matrix U. And then step 3, n is equal to n minus 1, a triangular number. So d1, d2, dk, and then I is equal to 1, j is equal to I plus 1, and then d is equal to aij. If aij is equal to -1, else go to 5.1.2. and so forth. So this is, these are the ways how you are going to proceed for the algorithm. If I is less than n minus 1, go to step 5.1. So this is type and else return to decimal value. So return the decimal values, that is d1, d2, dk, where k is greater than 1 and less than equal to r. And apply the RSA algorithm to receive the values of alpha 1, alpha 2, alpha k, for which is for d1, d2, dk. Decryption to receive the adjacent, to come back to the adjacency matrix. Input the numerical values, that is alpha 1, alpha 2, alpha k, k varying from 1 to r, and output is adjacency matrix A. Step 1, apply the RSA algorithm on the values alpha 1, alpha 2, alpha k to receive d1, d2, dk. Without -1, convert all the decimal numbers d1, d2, dk into binary numbers, and one can construct the required upper triangular matrix, and hence lower triangular matrix can be which is of the same kind, which is the transpose of this, can be considered, and diagonal entries will be 0, which will give the adjacency matrix. So all this is described here. So I think all this is being described up to step 10. So let us consider the example so that it is more easily understandable. So consider any map which shows several cities and route between these cities. Here every city is considered as a vertex and route between them are considered as edges. Where the situation is normal between the cities, we put the bold line considered as a positive edge, and abnormal situation, the route is considered as a negative edge. So these are the 7 cities, and the route between these two are between Kabul and Kalandhar is bit turmoil. So they have been shown by the negative lines and others are shown by the positive line. So now represent the map of cities into network as shown in the figure 4. This is this is the sign graph with respect to that network of cities. So now we construct the adjacency matrix. That is what is the method I was going on telling, by the means of algorithm, by the means of methodology also. So 0, 1, so this will be, so you can take the V1, V2, V3, V4, V7 and V1, V2, V4, V7 row wise and column wise, and V11, that is A11 will be equal to 0 because there is no loop. A12 will be equal to 1. A12 is 1. A12 is 1. A13 is also 1. A14 is 0 because there is no edge between 1 and 4. A15 is -1, A16 is 1 and A17 is 1, which you can see. And A17 is 0. Okay. So similarly, you can complete the whole matrix of the adjacency matrix. So this is the adjacency matrix. So number of elements in the given upper triangular matrix will be n square minus n by 2, that is 7 square minus 7 by 2, that is 21. So upper triangular matrix, if I go from this part to this part, these are 21 in number. These numbers are 21 in numbers. Above the principal diagonal, okay, the numbers here will be 21 in numbers. Okay, so applying encryption process, all the elements of the given upper triangular matrix will be represented as, okay, so how would you represent? So you will start from here. So this is the upper triangular matrix. So 1, then 0, 0, 0, 1. You have to write like that. 1, the string, how are you going to create the string? 1. Then come to the upper row, 0, 0, 0, 1. Okay. And then 1, 1, then 0, 0, 1, 0, sorry, 0, 1, then 0, 0, then 0, 0, 1, then 0, 0, 1, 0, 0, 0, 0, 0, 1, then 0, 1, minus 1, 0, and then 0, 1. Okay. So this is how you are going to get the string. This is the string. You are moving from the last row of the upper triangular, last row of the upper triangular matrix, and then the way I have been moving, you have to move like that. So you get, this is one string of the binary numbers. This is one decimal number, and this is another string of the binary number in this particular example. Now what we do, we add one more edge towards left of this and one more edge towards right of this. Okay. So this is the to convert two binary numbers to decimal numbers and 1 minus 1. So these are two binary numbers. This is one string of binary numbers. This is another string of binary number, and minus 1 is considered itself as a decimal number. So we convert this into a decimal number and 001 into a decimal number. So we first write the decimal number 1 and at the beginning and end of every binary number. So for the decimal number, we put 1 in the first binary string and 1 at the end, 1 in the beginning, 1 at the end. D2 is another binary number, that is minus 1, and the third binary number is 001. So you have put 1 in the beginning and 1 at the end. So now to convert the binary values of D1 and D2 into decimal numbers. So how we do, we know that how to convert the binary numbers into decimal numbers. So this is the number we are getting. Okay, and converting D3 into the decimal numbers. So this is 19 we are getting, and this is already a decimal number. So we have 3 decimal numbers in the particular example we have considered. One is 397835, and the other is minus 1, and the third one is 19. Therefore, for implementing encryption and decryption using RSA algorithm, we have 3 values of decimals in decimal. So input value of D1, D2, and encrypt. Now we go for the encryption. So input values of D1, D2, and D3. Choose 2 primes, 397 and 401. These are the 2 primes. And compute n is equal to p cross q. So you multiply these two, which will fetch this. Then compute the torsion function of n, that is p minus 1, q minus 1. So this will be 396 into 400. So that will give this value. Choose e such that according to the rule given, e was lying between 1 and 5n. E must be an integer, and greatest common divisor between e and n must be equal to 1. So E can be chosen as 23. Compute D such that D cross E and modulo phi n, reduce phi n must be equal to 1. So D cross E is considered as 23. So D into 23 modulo this is coming out equal to 1. And then D can be, so D, the value of D will be equal to 6887. So now the public key and the private key. Public key was given by EN, so 23. E is 23 and N capital is given by 159197, and private key is DN, that is 6887. 6887 is here, and then 159197. Okay, so encryption with public key. So alpha 1, now D1 raised to power E modulo n. So now we are converting alpha 1 into alpha 1. So alpha 1 will be this. Alpha 2 can be calculated in this by using this. It will be like this, and alpha 3. This formula was already given. Okay. So now thus we are able to, now the encrypted values of D1, D2, D3 are alpha 1, alpha 2, alpha 3 by these figures. For decryption, again we use public key DN, that is 6887 and 159197. Then input the alpha 1, alpha 2, alpha 3. So D1 will be, D1, D2 and D3 are calculated like this by using the formula. Okay, then after converting all the positive integers into binary numbers and reverse process, the upper triangular U matrix U is received, and after transpose of U, the lower triangular matrix L and U plus L equal to the adjacency matrix A is constructed, and once we have the adjacency matrix A, the graph can be retrieved. Thus, the encryption decryption mechanism can be applied to the sign graph matrices, and it will be more secure through implementation of RSA algorithm. So this is the chain that we are going to, that one can follow in this process. Input the adjacency matrix A or S of order n cross n. Apply an RSA encryption to convert S to decimal number. Convert the first as a single decimal number, 0 and 1 as a binary numbers for security reason. Number obtained is encrypted text, that is the alpha 1, alpha 2, alpha 3 of a type. Then apply RSA algorithm to obtain binary numbers. Text is encoded to sign graph matrix, that is decryption, and we can be able to obtain the original matrix. So this is what is the process that we have followed in this that I have followed in this talk along, and this paper was done along with my student Ubaid. So that is why he has taken the example of Afghanistan, because he's a student, he is from Afghanistan. So these are the references that has been used, and I, along with my student, has done many problems of such kind. So this is the paper in that direction along with Ubaid. So this paper is already coming in method 6. So a journal of Elsevier. So thank you so much for listening patiently. If there is any question, then one can ask.
Thank you, Professor Sinha, for such an eloquent lecture on such a pertinent topic. Thank you very much.
Thank you, sir.
Now this is my duty. This is my duty to hand you over this digitally this certificate of lecture delivery, and you will be getting it in due course of time. We will be sending it to you.
Yes.
And this is the memento.
Yeah. Thank you. Thank you.
Thank you, ma'am.
It would have been good if I would have been there to receive it.
We wish, ma'am, certainly we have a different level of feeling.
I was really busy, and I'm very delighted to see my student Praveen peeping.
Thank you. Thank you.
Thank you. Thank you.
Thank you very much for sparing your valuable time with us. We are very blessed.
Thank you. Thank you. It was my honor.
Thank you. Thank you. Over to Sarat sir.
Thank you. Thank you, Professor Deepa Sinha ma'am, and thank you, Professor Paresh Vyas sir, for chairing the session. Good evening, everyone. Moving forward, we have today's last technical session, which is paper presentation session, and the most awaited session of the participants or delegates. So for this, I request all the paper presenters to move towards their respective rooms. I think everyone is knowing where is their presentation scheduled. So please.
Just 1 minute. I also want to thank this. I'm very much delighted to see Dr. Amla Olkha and Nidhi Srivastava, Nidhi Khandelwal. So I could see them moving here and there and introducing the my other ex-colleagues. And so it was really nice to see them. Thank you.
To continue this, I feel privileged to invite Mr. Rajesh Kasana and Dr. Praveen Garg sir to chair the session. And for a smooth functioning of the session, I request all the paper presenters to please upload or email their presentations on the system, if not done earlier. And now I request Dr. Praveen Garg sir to please begin the session.
Thank you, Dr. Sarath.
Today's conference first talk invite to Sonu Kumar Saini for your presentation. Sonu Saini. Next, Mukesh Kumar.
Good evening, all of you. My name is Mukesh Kumar. Today I present my paper titled Caisson Fluid Flow in the Vertical Anomalous through Porous Medium with Heat Transfer Characteristics and a Chemical Reaction and Exact Solution. Under the supervision of Dr. Amla Olkha ma'am, there are outlines, abstract mathematical formulation, exact solution, result and discussion and conclusion. Next. Abstract. The present study the explore heat and mass transport in natural convention of Caisson fluid in vertical anomalous by porous medium. Impact of thermal radiation, heat source, chemical reaction are taken into consideration, and the equation representing the model reduced into non-dimensional only differential equation under the acquired transformation are solved analytically. Closed form solution are obtained for the problem in the term of Bessel function influence of various arising parameters such as porous medium, heat generation, thermal radiation, thermal Kirchhoff number, solutal Kirchhoff number, etc. on the flow, temperature, and concentration field are exhibited by graph and discussed. Also, we have solved the problem numerically on MATLAB software employing the B4C technique along with the shooting technique. The exact solution and numerical solution are compared, found a good match. Moreover, the effect of numerous parameters on quantities of physical importance such as skin friction coefficient, Nusselt number, and Seyfert number are also portrayed and discussed. Heat exchanger and energy storage systems such as batteries and inverters, thermal storage, and the thermal protection system are okay. Thank you. Mathematical formation, we consider the two-dimensional flow state flow of a Caisson fluid in the angular region taken to infinite long concentration vertical cylinder by porous medium. Next, there are governing equation in the dimensional form given by with help of these quantities we reduce in non-dimensional form. Next. And corresponding boundary condition. These equations are Bessel differential equation is can be solved easily. Then solution equation 6 to 8 are Bessel differential equation. Under boundary condition, solution of this equation obtained as equation 10 to 12. In this figure, we see that the velocity profile increases with the increasing value of Caisson fluid parameter beta. Next. Here, velocity profile declined with the increasing value of porous medium parameter and Kirchhoff number. Next, and reload numbers and radius ratio and heat source. Temperature profile increases with the heat source parameter. Next, next conclusion date last. Okay. Okay, velocity increases with increasing value of Newtonian parameters, heat source, and Kirchhoff number, radius ratio, and trade is reverse for porous medium, Reynolds numbers, chemical reaction, and thermal radiations. Temperature profile enhanced for improving value of heat source parameter, and trade is reverse for radius ratio and thermal radiation parameter, and concentration profile reduces with increasing value of chemical reaction parameter and radius ratio. Next. Skin friction decline with increasing value of porous medium parameter, Reynolds numbers. Thank you.
Any question? No. Next, Sonu Kumar Saini.
Good evening, all of you. Myself, Sonu Kumar Saini, research scholar under the supervision of Dr. Rasmi Agrawal, Department of Mathematics, University of Rajasthan. The title of my article is Impacts of Activation Energy and Convective Heat Transfer on the Williamson Nanofluid Flow over a radially stretching sheet with Joule heating and thermal radiation. These are outlines, introduction, mathematical modeling, methodology, analysis, conclusion, and references. This is the introduction. Nanofluids have gained considerable interest due to its outstanding thermal properties, which are particularly helpful in the technical and engineering fields, like cooling of transform oil, hybrid power energy, direct weathering, cooling, and so forth. In contrast to conventional floods, it is projected that the solid nanoparticles would be able to increase the rate of heat transfer and thermal conductivity. So essentially, these are modeling by presuming infinite shear rate viscosity. The equation number 1 is converted to in this. Mu is the infinite shear viscosity. It is defined for Williamson fluid flow. And next, these are governing equations. Next, these are fluid model and the geometry of the flow. This is radially stretching sheet, and below is a list of fundamental suppositions for the proposed model: unsteady flow, Williamson model, porous medium, viscous dissipation, and Joule heating effects. Next, and nonlinear thermal radiation, partial velocity slip condition, impact of activation energy on chemical reaction. Based on the aforementioned hypothesis, the model equations for nanoparticle flow these are non-dimension form of the equations, governing equations, and these are similarity transformation, which is used to transform the governing equation into non-dimensional forms. Next, and these are boundary condition in non-dimensional form. Next, these are parameters which are used here. Next, and here the methodology, the Galerkin-weighted residual method is used for solve the non-dimensional governing equations. Next, these are the graphs, velocity field behavior in connection with magnetic parameter on the temperature profile. Next, these are conclusion. The prevailing values of the harness activation energy parameter, unsteady parameter, the wave numbers, and the thermophoresis parameter boost the nanoparticle concentration profile, but the Brownian motion parameter has the reverse impact on the concentration profile. Indeed, the fact that a porous medium enhances the solitary boundary layer associate thickness. When the thermophoresis and Brownian parameters are strained, the local Nusselt number tends to drop, but the temperature ratio parameter has exactly opposite impact. The Smith number, thermophoresis, and Brownian motion all have proportional implication on the Sherwood number, although the activation energy parameters has an adverse influence. These are the reference. Thank you.
Thank you, Mr. Sir. Anyone question? No? Next, Rahul Kumar Chaudhary.
Good evening. Good evening, all of you. My name is Rahul Chaudhary. Today, paper presentation: melting, heat transfer, and entropy generation in viscous flow over a curved surface with viscous dissipation and chemical reactions. Next. These are outlines. Next. Abstract. Keywords: curves, stretching sheet, melting, heat transfer, non-uniform heat source, viscous dissipation, non-linear radiation, chemical reaction, and entropy generation. These are governing equations. Graph. Next graph. First profile decrease with section injection, porous medium, and melting source. Figure second, velocity profile increase with stretching sheet. Next. Temperature profile decrease with Prandtl number, ME, and so S. Figure 4, temperature profile for A star, B star, and D. Next. Temperature profile increase with A star and B star. Figure 6 temperature profile increase with BR, theta W and radiation. Next. Concentration profile for Kn and S. Concentration profile decrease with Kn and Sc. Concentration profile increase with N. Next. Entropy generation profile with BR, with entropy generation profile increasing with BR, entropy generation. Figure 10 entropy generation profile increase with radiation. Next. Next. Entropy generation profile for omega, entropy generation profile for N. Both are decreasing. Next. Entropy generation profile increasing with lambda 1 and entropy generation profile increasing with lambda 2. These are comparison of skin friction coefficients, Abbas et al. And present studies. Next. These are references. Thank you.
Thank you. Next, Kuldeep Singh. No? Pooja Agarwal? Hi.
Good evening, all of you. My title of my study is Numerical Study of Tourette Effect and Activation Energy in Power Layering Model. Next, sir. These are the outlines of my presentation: abstract, introduction, mathematical modeling, numerical technique, results and conclusions. Sir, next. Abstract of my study is this: the aims of the study to investigate the Tourette effect and magnetohydrodynamics, flow, mass and heat transfer in power layering model over a linearly stretched sheet with activation energy and radiation. First, we using the similarity transformation, non-linear partial differential equation are reduced into the ordinary differential equation, and by the help of BVP4C technique, by the help of BVP4C technique, effects on many parameters like velocity, temperature, concentration are presented through graphs and tabulated. This is, sir, schematic diagram. This is the schematic diagram of my study. This is two-dimensional study. In x-axis the velocity is u, and the y-axis the velocity is v. Boundary condition are shown, and the at y equals to 0 the velocity is uw in x direction, and the velocity is 0 in y direction. The temperature T equals to TW and the concentration is C equals to TW. There are three layers in this schematic diagram. First layer is the momentum layer, second is the thermal, and the third one is the concentration layer. Next, sir. This is the mathematical modeling of my presentation. First equation is the equation of continuity, second equation is the equation of momentum, third one is the equation of temperature, and fourth is the equation of concentration. Next, sir. Equation 5, these are the similarity transformation, and equation 6 and 7 are represent the boundary conditions. Next, sir. By using the similarity transformation, equation 2, 3 and 4 are converted in equation 8, 9, 10, 10, and the boundary condition 6 and 7 are converted in boundary condition 11, 10, 12. These are these conditions are in non-dimensional form. Next, sir. This is the numerical technique by BBP4C coding by BBP4 use the BBP4C method. First, we convert all the non-dimensional form equations in first order differential equation, and then after convert these equation in first order differential equation, we by the help of MATLAB software. Next, sir. We conclude these graphs. The first graph shows the impact of radiation parameter on temperature. The second graph shows the impact of Prandtl number on temperature. Next graph. Next graph shows the effect of magnetic parameter on velocity. Next graph shows the impact of Eckert number on temperature. Next graph shows the impact of heat source parameter delta on temperature. Next graph shows the impact of Schmidt number on concentration. Next graph shows the Soret impact of Soret number on file. Since the title of my study is Soret, so this is the very important graph, impact of Soret number on concentration. Next graph is the P on pi. Here P is the reaction rate parameter. Next, sir. The conclusion of my study is this: fluid velocity decreases with increase in magnetic parameter. Fluid temperature increase with the increase in radiation parameter, Eckert number, and heat source parameter. Fluid temperature decreases with increase in Prandtl number. Fluid concentration decreases with increase in Schmidt number. Concentration of the fluid declines with rise in Schmidt number. P is reaction rate parameter, PR is Prandtl number, and D is the difference of temperature. Next, these are the references. Thank you. Any query?
ये जो आपने डेल्टा का इफेक्ट दिखाया टेम्परेचर पे, एक बार ग्राफ दिखाइए सर।
हाँ जी।
इफेक्ट ऑफ डेल्टा ऑन टेम्परेचर।
Yes.
कन्वर्ट करना है?
Yes, this graph is according to the boundary conditions. As boundary, according to the boundary condition, the theta is between 0 and 1. Then this graph is also between 0 and 1, lie between 0 and 1. Sir, we from y-axis, the upper point is 1.
जानना चाह रहा मैं, जैसे आपने इम्पैक्ट ऑफ एम ऑन एफ ईटा दिखाया, उसमें साफ साफ दिखाया कन्वर्ज कर रहे हैं, सारे एक जगह जाके इकट्ठे हो रहे हैं। जो आपने इम्पैक्ट ऑफ डेल्टा ऑन थीटा दिखाया, वो जाके ऐसा लगा कि टाइम के बाद में अगर आप आगे बढ़ोगे मीटर की वैल्यू तो कट करता हुआ दिखाई देगा उसको।
सर अकॉर्डिंग, एक्चुअली मुझे लर्न तो नहीं है मैंने कितना रखा, बट अकॉर्डिंग टू द बेस पेपर आई कंक्लूड दिस।
ओके ओके,
थैंक यू सर।
थैंक यू। नेक्स्ट भगवान सिंह यादव।
Good evening, all of you. My name is Parvinder Yadav. I am a student, Department of Mathematics, University of Rajasthan, Jaipur. My topic of presentation is slip effect and entropy generation in third grade non-Newtonian fluid flow in partially filled channel. Next slide. Formulation of problem. We consider fully developed steady laminar flow of non-Newtonian fluid of third grade in composite channel bounded by two infinite parallel. Next slide. This is geometry of problem. In this geometry, x-axis and x-axis and z-axis lying in lower channel walls and y-axis normal to it. The fluid flow divided two regions. One region is post-medium region and second region is clear fluid region. The governing momentum and transformation equation of incompressible non-Newtonian fluid of third grade in composite channel, equation 1 to 4. Next slide. Next slide. The appropriate boundary and interface condition, equation 5 to 7. Next slide. These equations made non-dimensional using this transformation, transformation 8 and non-dimensional equation 9 to 12. Next slide. Next slide. and corresponding non-dimensional condition is equation 13 to equation 15. Next slide. Method of solution, a domain decomposition method. Next slide. In equation 9 to 12, second order differential coefficient is the highest order linear term, and therefore these equation can be expressed as equation 13 to 16. Next slide. Operating the inverse operator of both side equation 13 and 16, we have equation 17 and 20. By use of ADM, the solution can be expressed in the form of infinite series. These equation 17 to 20 gives equation 21. Next slide. Where x and y and pn and qn are a domain polynomial. Equation 22 represent a domain polynomial. Equation 23 a domain polynomial of first order. Next slide. Zeroth order solution is represent equation 24. And zeroth order boundary condition is equation 25. First order solution can be expressed as equation 26 and the corresponding boundary condition are 27. Next slide. The first order solution is expressed as 28. Second order solution can be expressed 29 and corresponding boundary condition are equation 30. The second order solution is expressed equation 31. Next slide. We obtain results are plotted for different value of the involved physical parameters. Next slide. In this figure, velocity decreases with increasing value of non-Newtonian parameter beta star. In this figure, velocity increases with increasing value of velocity slip parameter gamma. In this figure, velocity increasing with increasing value of non-dimensional pressure gradient P. Next slide. In this figure, effect of viscosity ratio parameter N on viscous velocity distribution. In this figure, velocity decreases with increasing value of viscosity ratio parameter N. Next slide. In this figure, temperature distribution increasing with increasing value of temperature slip parameter beta star in porous medium region and lower part of clear fluid region, but trend reverse in interface line. Next slide. The same effect of Brickman number on temperature distribution. Next slide. In this figure, temperature distribution. In this figure, temperature distribution decreases with increasing value of thermal conductivity ratio parameter M in entire region. Next slide. In this figure, entropy generation number increases with increasing value of Brickman number gamma. Next slide. Conclusion. Velocity slip parameter gamma substantially enhances the fluid flow, while non-Newtonian parameter beta star reduce it. Effect of viscosity ratio parameter N is noticed to decrease the flow field. Next slide. Effect of thermal conductivity ratio parameter M is found to reduce the temperature in both the region. Entropy generation N increases with increasing of Brickman number, but effect of thermal conductivity ratio parameter M and temperature slip parameter beta is noticed to reduce it. Next slide. These are references. Thank you.
Thank you, Rajan. Next, Balakishan Vaishnav.
Good evening to all. Today, I am very happy to participate in this international conference as a research scholar student of the Department of Mathematics, University of Rajasthan, Jaipur. I done my PhD under the supervision of Dr. Sushila Chaudhary. Title of this paper presentation is MHD micropolar fluid flow over a curved stretching sheet with thermal radiation and chemical reaction. Next, sir. These are the content of this presentation. Next, sir. Abstract. In this paper, I study the heat and mass transfer over a curved stretching sheet for micropolar fluid. In this paper, first I convert the non-linear partial differential equation using the similarity transformation and convert to ordinary differential equation. Then using the MATLAB software, I solve this problem and getting the results. Next, sir. In this micropolar fluid, I use the curved stretching surface when R is the radius of curvature. Perpendicular direction small r is the direction, and second direction is in the direction of curved, taking as a s. In this direction, you denote the velocity, and perpendicular direction B shows the perpendicular velocity. Next, sir. These are the mathematical formulation of the problem. Equation 1 denote the equation of continuity. Equation 2 is the equation of pressure. Equation 3 denote the equation of momentum. Next, sir. Equation 4 denote the equation of angular momentum. Equation 5 denote the equation for temperature. Next, sir. Equation 6 denote the equation of concentration. For solving the above problems, we use the boundary condition denoted in the equation of 7. Next, sir. Using the similarity transformation denoted in the equation 8, we obtain equation 9, equation 10. Next, sir. And equation 11, 12, and 13. Using, next, sir. Using the equation from 9 to, using the equation, I think 6, convert, using the equation 7, similarity transformation, we convert the boundary condition denoted in equation 14. 16 denote the parameters we can define in these problems. We solved our equations using the 14 number as a MATLAB software using BP4C method. Next, sir. Next. This graph shows the temperature profile for different values of thermal radiation parameters. Next. Another graph shows temperature profile for different values of Prandtl number. Second, next, sir. This graph shows the velocity profile for different values of permeability parameters. Next, sir. This graph shows velocity profile for different values of magnetic parameters. This graph shows concentration profile for different values of chemical reaction parameters. Another, sir. This graph shows concentration profiles for different values of Schichman numbers. Conclusion. In this paper, mass and heat transfer of MHD micropolar fluid over a curved stretching sheet with the influence of thermal radiation and chemical reaction have been evaluated and compared with the well-known results. The main results shown in this, the temperature profile decreases with the increasing value of Prandtl number. Because of boundary layer thickness becomes, when Prandtl number increases, boundary layer thickness is decreases, which is the reason for the temperature profile decreases. Another is when temperature profile decreases when increasing values of radiation parameter. In this sense, when radiation parameter increases, absorption coefficient is decreases. This is the reason for temperature profile decreases. Another is velocity profile decreases with the increasing values of magnetic parameter. Because of when we increases magnetic parameter, Lorentz force induced which oppose the flow of fluid. Another is the velocity profile decreases with permeability parameter. Because of when permeability parameter is increases, the whole of porosity is decreases. Whole of porosity decreases whenever velocity profile is decreases. Another is concentration profile increases with the decreasing value of cis-main number because of buoyancy effect. And another is concentration profile increases with the decreasing value of chemical reaction parameter. In this chemical reaction parameter, boundary layer thickness becomes thin. Next, sir. These are the references. Thank you, sir.
Thank you, Balkishan. Any question? Next, Prachi Gupta.
वो माइक लो माइक लो नीचे करो हाँ नीचे करो ऑन भी करो इसको यहाँ फोन आया मत घर आ गए बिल्कुल बार
Next. Introduction. There are many applications such as condenser, power plant, engine cooling, thermal energy storage devices, groundwater system, paper industry, polymer industry, and high temperature nanomaterial technology where a high rate of heat transfer are required. So many methods are given by scientists and engineers to enhance the rate of heat transfer. Among them, one method is in which particles are added to base fluid. Nanoparticles have great capacity to enhance the heat transfer rate, which are mixed in different base fluid like water, ethylene glycol, oil, etc., and make nanofluid. These nanoparticles can be carbon. Next. Mathematical formulation. This is flow diagram of my problem. Next. Study 2D viscous incompressible mixed convective laminar flow of hybrid nanofluid over two different geometries, cone and bases taken in account. X-axis is along the wall of geometries and y-axis taken in normal to it. We consider permeable geometries through which fluid is flowing and external magnetic field B is applied parallel to y-axis. Brownian motion and thermophoresis effects are considered with due heating and chemical reaction effects in porous medium. Governing equations are given by equation. First is equation of continuity, second is equation of momentum, third is equation of energy, fourth is equation of concentration with boundary condition 5. Next.
Method of solution पे चलिए.
We use equation 6 as similarity transformation, then equation of continuity is identically satisfied and equation 2 to 5 reduced in equation 7, 8, 9 and 10 where differentiation done with respect to eta. Next. These are parameters. Next. The expression for skin friction coefficient, Nusselt number, Sherwood number are given by equation 11. We applied BVP 5C technique. Next. Next. Result and discussion. These are some graphs. Next. Next. Last conclusion. Conclusion: following results of this work are concluded as first is there is a proportionality between fluid temperature and mZ1, Z2, NT, and EC, and inverse effects can be seen for K as Prandtl R1. Fluid temperature is always greater for wedge as compared to cone. Second is a parallel relation exists between fluid concentration and MNT, or inverse relation occurs for K as NBR2 Smith number. Third is thermal and concentration boundary layer are thicker for wedge and lesser for cone. Fourth is Nusselt number decreases with the increase in M, Z1, Z2, NT, NB, Eckert number. These effects are greater for wedge as compared to cone, and opposite results comes for K as Prandtl R1. Fifth is Sherwood number diminishes more for wedge and lesser for cone for higher values of M, NT, and inverse impact is noted for K as NB R1 SC, KR star. These are some references which are used. Thank you very much.
Thank you, Prachi. Next, Yada.
Good evening, all of you. I'm Manvi Ada here to present my paper. Title has Irreversibility Analysis for Non-Newtonian Couté Thermodynamics with Asymmetric Cooling using Differential Transform Method under the supervision of Professor Paresh Vyas. Next. Introduction of my paper. In this paper, semi-analytical differential transform method is invoked to treat non-Newtonian Couté thermodynamics. Next. This is the schematic diagram of mathematical model. Here we are considering a channel fluid flow, which has the upper wall is impermeable and moving with a constant velocity capital U0, and the lower wall is natural permeable base, and these are the temperature condition. Here we use asymmetric cooling. Next. These are the governing equation 1 and 2 and boundary condition in equation number 3, and equation number 4 is the non-dimensional quantities. Using the equation 4 non-dimensional quantities, we will obtain next. These non-dimensional equations, equation number 5 or 6, and boundary conditions are in equation number 7. Here in this study, we computed skin friction and Nusselt number as well. Here the formula and the calculation given in this slide. Next. Method of solution. The non-dimensional governing equation has been solved with using differential transform method. Here the brief explanation of differential transform I have given. Actually, the differential transform method is a basically Taylor series explanation, and with the transformation equation and using the recurrence relation as well and the inverse transformation method, we get the solution in the form of power series, and power series is convergent power series. Next. Using the differential transform method in the non-dimensional equation 5 and 6, we get equation number 12 and 13 transform the equations, and the transform boundary conditions are in equation number 14. Next. These are the some constants in power series. Next. Using the inverse transformation, we get F eta and theta eta in the form of power series, and we can see we use the some basic constant and we get the particular solution, and in the particular solution we can see the constants are convergent. We also study the thermodynamics irreversibility. The equation number 25, 26, 27 shows 26 shows the entropy and the 27 is the Bayesian number. Next. In this paper, we have compared the result, the DTM method result with the already Maple inbuilt RK45 method, and we can see that the results are almost equal. Next. These are the table for skin fraction and Nusselt number. I will discuss only one. Okay. We can see that when we increase magnetic parameter 1 to 2.5, we can see the skin friction at the lower wall y equal 0 is decreasing. That means the velocity gradient is decreasing, and as well at the, okay, next. These are the graphs. Next. Conclusion. The conclusion is basically for the skin friction and Nusselt number table, which I have already discussed for one parameter, and these are with the other parameter as well. We can see the Hartmann number, slip parameter alpha, the non-Newtonian parameter with N, and Brinkmann number. The skin friction is increasing and Nusselt number is decreasing, and increasing velocity gradient and temperature gradient as well. These are the references, and thank you.
Thank you, Manvi. Next, Khushbu Bhaskar.
Good evening. Myself, Dr. Khushbu Bhaskar. I am assistant professor in Department of Mathematics, SSN Subodh PG Autonomous College, Jaipur. I am going to present here my research paper with the title Heat Transfer Analysis of Cross-Diffusive Copper Water-Based Nanofluid Flow Between Non-Parallel Stretching Sinking Walls. Next. And the present paper deals with incompressible nanofluid flow inside stretching sinking walls. The flow is contemplated from a source or sink through channel. The influence of various effects such as MSD, heat source sink, and cross diffusion effects are also taken into consideration. This problem is firstly converted into dimensionless form after using the suitable symmetry transformation, and then solved by using OHM method, means optimal homotopy analysis method. And then a valuable agreement is obtained on comparing the result with previous published research papers. So next. Basically, nanofluid is a fluid which consisting the nanomaterial size particles, which is consist between 1 to 100 nanometer size particles. And nanofluid, these nanoparticles are made by metals, oxide, carbide, and carbon nanofluid, and water, ethylene glycol, and oil treats as base fluid. The next.
Mathematical formula.
This is the mathematical problem for this current study. Here the fluid flow is considered between two non-parallel stretching shrinking walls. The flow is contemplated from a source or sink which is placed at the meeting point of the non-parallel walls. BGO is the applied magnetic field. Both the plates are stretchable with the angle 2 alpha. These are the governing differential equation. Equation 1 shows the equation of continuity. Equation 2 and 3 shows the velocity in r and theta direction. Equation of motion, and equation 4 shows the equation of energy. Equation 5 is the equation of species, and equation 6 shows the boundary conditions at the angle theta is equals to 0 and theta is equals to plus minus alpha, where alpha is the angle of convergent divergent. If alpha is less than 0, it means the channel is convergent, and when alpha is greater than 0, it shows the divergent channel. The governing differential equation are firstly reduces into the dimensionless form after using a suitable symmetry transformation. These are the reduced equations. Here R is the Reynolds number, M is the magnetic field, RD is the radiation parameter, HS is the heat source parameter, EC is the Occult number, PR shows the Prandtl number, and DF is the Dufford number. And in equation number 9, SC is the Smith number, K is the chemical reaction parameter, and SR is the solid number. And equation 10 shows the reduced boundary condition. Here C star shows the stretching shrinking parameter. When C star is greater than 0, it shows the stretching, and when C star is less than 0, then it shows the shrinkness of the plates. Methodology. To solve the governing differential equation, there are various numerical and analytical methods. Which method are used is the semi-analytical method. The name is optimal homotopy analysis method. This method is dependent on small and large physical parameters, and this method gives the opportunity to select the base function which satisfy the boundary conditions. OM is an easy way to calibrate and convergent the solution. Results and discussion. Here the effect of various non-dimensional parameters such as magnetic parameter, Reynolds number, radiation parameter, heat source parameter, Prandtl number, Arkart number, Duffer number, chemical reaction parameter, Smith number, along with the solid number is shown through figure 2 to figure 4.9. In this study, there are approximately 50 graphs. So,
continue.
Conclusion. So back, slide पे back. Table 2, 3, 4, and 5 shows the accuracy of our present result with the previous published research work. It shows a very good agreement. The next. Conclusion. The major outcome of this investigation are as follows. Magnetic parameter enhances the velocity and temperature profile in both convergent, divergent, stretching, shrinking channel. An increment in Reynolds number, opening angle, and nanoparticles volume fraction causes a reduction in velocity profile in stretching, shrinking, divergent channel and enhances in stretching, shrinking, convergent channel. Nanofluid velocity, temperature, and concentration profile enhances with the stretching parameter, while they decreases in shrinking parameter for divergent and convergent channel. An increment in radiation parameter, Reynolds number, heat source, and nanoparticle volume fraction, the temperature profile decreases. The higher values of opening angle alpha, Prandtl number, Arkart number, Duffer number, and solid number enhances the temperature profile, and the concentration profile increases with the opening angle alpha and nanoparticles volume fraction, where it shows the opposite behavior for higher values of Duffer number, Smith number, chemical reaction parameter, and solid number. These are the related references. Thank you.
So, any question, participants?
Because an increment, generally an increment in magnetic parameter generally decreases the velocity, but here an increment in magnetic parameter enhances the velocity near the lower plate of the channel, while an increment in magnetic parameter reduces the backflow. That's why here velocity increases for higher values of magnetic parameter. Higher values of magnetic parameter reduces the backflow in the channel. This is the reason for an increment.
मेरा बचा है
मैं चला जाता हूँ नहीं मैं बोल देता हूँ कौन सा किस नंबर पे फर्स्ट है now I invite Mr. Rajesh Kumar Kasana to present his topic.
गुड मॉर्निंग सभी साथियों को नमस्कार। मैं राजेश कुमार कसाना आज के इस कॉन्फ्रेंस में मैं कपल स्ट्रेस विलियमसन फ्लूइड फ्लो एंड एंट्रोपी इन फोर्सिमर कंपोजिट वर्टिकल चैनल विद डिफरेंशियल ट्रांसफॉर्म मेथड के बारे में चर्चा करूंगा। मैं डॉक्टर प्रेस व्यास के अंडर में पीएचडी कर रहा हूं और वर्तमान में असिस्टेंट प्रोफेसर एसबी के गवर्नमेंट पीजी कॉलेज जैसलमेर में कार्यरत हूं। नेक्स्ट सर। These are the contents of my paper: abstract physical sketch of the problem, mathematical formulation, similarity transformation, solution, entropy discussion, graphs and references. Next. Abstract: the entropy generation is a flow fields and thermal fields proposed by Williamson fluid, and the focus on the present article. The vertical forcible composite channel was subject to a couple stress of fluid flow. The vertical channel is partially filled with a porous material, and both the left and right wall of the channel are subject to a constant injection velocity. On the other hand, the constant suction velocity is applied to right wall of the channel. The differential transform method is used to convert the non-dimensional to solve the non-dimensional equations. This is the physical sketch of my problem. There are region first is porous medium and region second is a clear fluid region. Next, these are the mathematical equations for region first and region second. Region first is porous region and second is clear fluid region. Next, sir. These are the corresponding boundary conditions given by equation number 5. Next. These are the non-dimensional quantities which are used in equation 1 to 5 solving. Next, sir. And using equation 5 in using equation 6 in equation 1 to 5, we find the non-dimensional form of governing equations given by equation 7 to 10. Next. And the corresponding boundary condition are given by equation 11. Next, sir. Solving methodology by differential transform method. First of all, we convert the given non-dimensional equation by discretize the differential transform method for both region first porous region and region second clear fluid region, which are given by equation 12 and 13 for porous region. Next, sir. And equation 14 and 15 are given by for clear fluid region. Next, sir. These are the corresponding boundary condition for both the region, and matching boundary condition is taken as initial boundary condition for this problem. Next, sir. These are the series solution for the problem which is solved by differential transform method. Next, sir. And the next section is the entropy generation analysis, which is given by equation 18 and 19 with characteristic entropy and temperature ratio. Next, sir. The porous region and clear fluid region, the non-dimensional entropy is given by equation 20 and 21. Next, sir. These are the graphs of the problem. When variation in entropy and Bézier number, as a material parameter delta is varying, and we see that in region first and region second, when delta is increasing, as a entropy is also increasing for region first, but we see in reverse trend in region second, and in Bézier number we see that a middle trend in a region first and region second. Next, sir. Variation in entropy and Bézier number as a k varying, we see in region first as a k is varying increasing for both regions, as entropy and Bézier number is also increasing. Next, sir. Variation in entropy generation and Bézier number as varying pressure gradient in both region, entropy and Bézier number is decreasing as varying P. Next, sir. Variation in entropy generation number and Bézier number as varying Brinkman number. Entropy, we see that as increasing Brinkman number for region first, entropy is increasing, and also for region second, entropy is increasing. But Bézier number has a reverse trend in both regions. Next, sir. Figure 9 and 10 show that variation in entropy and Bézier number as a Williamson parameter is increasing in region first, as increasing, then entropy is also increasing, and region second also increasing. But in Bézier number, in Williamson, the Bézier number has a inverse trend, either increasing in half interval and decreasing in half interval. Next. Variation in entropy generation number and Bézier number has very 4 number for both the region, entropy and Bézier number. Next, sir.
variation in entropy number and Bézier number for Grashof number, we have seen that entropy for both region first and second, as Grashof number is increasing, entropy is also increasing, but for Bézier number, when Grashof number is increasing, we have region first a reverse trend, and in region second, we have see that when Grashof number is increasing, Bézier number is decreasing. Next, sir. Variation in entropy generation number and Bézier number as phi1 is increasing, Bézier number and entropy is decreasing. Next, sir. Or also we see that phi2 we have a trend as phi2 is increasing, Bézier number and entropy is decreasing.
Please come to the conclusions.
Yes, sir. These are the differences. Thank you, sir.
Thank you. One question. डिफरेंशियल ट्रांसफॉर्म मेथड कहाँ से सीखेंगे? क्या कंटेंट है उसका?
सर पहली तो ये है कि ऑनलाइन तो आपको एक ऑर्डर की डिफरेंशियल इक्वेशन का मिल जाएगा,
ठीक है,
लेकिन अगर इसको आप एक रिकरेंस रिलेशन बनता है सर इसमें मोस्टली आप अगर उस रिकरेंस रिलेशन की सहायता से आप काम करोगे तो मैं प्रोग्रामिंग के थ्रू दिखा सकते हैं आपको। एक्चुअली प्रोग्रामिंग डेवलपर हमारे साथ अभी एब्सेंट है शहनवाज, और तो वो ज्यादा बेटर बता सकते हैं।
ठीक, थैंक यू Mr. Kasana for chairing this session and this presentation, and thanks to the delegates for their patience, listening and cooperation. You all are requested to please be present tomorrow in the department at 9 o'clock. Your breakfast is arranged here. Thank you.